Are we live? Apparently, we're live. Right, okay. So let's... I don't know what's going on. Yeah, excuse me. The streaming stuff, I signed in with YouTube yesterday. I'm assuming we're live. Let's just see. Yes, okay, so... Let me explain what's going on. Like, why am I asking this question? Let's just go to top chats. Okay, live chat. Okay, so people, I wanted to improve the stream a little bit by like showing, you know, your contributions to the stream to come up on the actual stream. Hi bot. You know, if you know, hypothetically, if someone donated, right? I'm just explaining what was going on. And this streaming software, I won't go into it too much, has completely now changed up on me and the way I was streaming before. Yeah, so yeah, there we go. There was a donation link. I don't know where that donation link went or what it does. So yeah, I'm gonna leave that alone for a bit. Yes, hi guys. That's why it took a minute to get going. As we are professional streamers, this is inevitable. So yes. Anyway. So in theory, if you weren't subscribed, I hope, you know, if you weren't subscribed to the YouTube channel, it should tell you that you subscribed on the screen. I don't know. I don't know if you can even test it by unsubscribing and then resubscribing. We'll see. We'll see it. You'll have to let me know. I think there'll be a sound effect that plays. I don't know. But yeah, so basically, the stream is hopefully set up in a way that, you know, if someone is to donate, it'll come up on the screen and kind of be like a nicer thing for them. I donate, but all I have is in cash. I donate, but all I have is cash. Oh yeah, no problem. No one has to donate. I pick up whatever I see, and somehow all of it's in mint condition. Huh. Are you... Oh, I see. You just, like, kind of collect your cash together. Yeah, no, but there is no... obviously, it's always appreciated when people do donate. But anyone is allowed to, you know... anyone is welcome to just, you know, chill, watch the streams. That's why I do them, right? It's like... I want to provide value for free, so, you know, that's the thing. Any additional thing on top of that is obviously extremely nice, but it's not necessary. The fact that anyone turns up here at all and watches anything, so that's enough, right? Everyone's job in the chat is to sit back and have fun, whatever that may be. It doesn't work that way. Knock knock. Hi Ratchet. Is this working? I think so. I have to leave. Okay, but see you soon. Hi, Gemma. Hopefully you're having a good day today. Thank you for the lovely compliment. Yes, so I should have... Let me just make sure this is on. I think. So I have this thing that I was trying to get working yesterday. Obviously, you can't see that for reasons... security reasons, but yes, there should be something. I don't know. I really have no idea. Maybe we should play a sound effect. Oh, there we go. That's what it should do. Save this. So yeah, in theory, it should do something like this, right? I don't know if it will. We'll see. So that's the idea. That's why everything took a minute to get working. I just checked, your last video has 40k views. Crazy. I know, it's great stuff, isn't it? It has been kind of nuts. That video was honestly, I made it for... I had one person in mind when I made that video, and I thought this might apply for 3 people. The fact it resonated with so many people is kind of nuts. I literally expected to get 100 views, if that. And it was literally meant for people who join the live streams regularly. That's literally who it was meant for. But there we go. It struck a chord, obviously. But yeah. Anyways, enough YouTube and streaming yap. What are we doing today? Okay, so yesterday I did do work after the stream, and I figured out my issue. It was pretty kind of obvious. Like, people who are good at this programming stuff, you know, other than me, will probably roll their eyes and say, "Escape point, you did it again. You made the same mistake again." Yes. It turns out I had a out of bounds buffer read for a buffer that I was accessing via an instance, and this meant that when I had two elements, or when I had one element, it was fine. When I had two elements, it was glitchy. When I had three elements, it kind of went weird. When I had 5 elements, finally the synchronization validation kicked in and went, "Oh, you've got an out of bounds buffer read." So, yeah, it was basically I've learned it. I've learned this the hard way. Wow, thanks, Emmanuel. Flippin' heck, did it? Wow, thank you so much. Did it come up on the thing? I wish it did. Oh no, maybe it doesn't work. That's I don't know if it did, because I don't have the stream running. Thank you so much. I'll display it. There we go. Look, at the very least we can have this here. Yeah, it looks the same. Morning. So there we go. We got a lovely live chat. I'll put that there. I'll make a big deal of it. Even if the bot won't. I guess it's not working. Maybe it's no. I think it's just me not setting it up properly. I thought I set it up properly, but I guess I didn't. But anyway, I will make a big deal of it. Thank you so much for the NGN 200 NGNs. I assume you saw my compression testing on Discord. Yes, very. I'm very impressed, actually. I was replying to a lot of things, and I thought, you know, if I don't get on with my own stuff, I'm just going to be replying to Discord all day. But yes, it was very cool. So yes, Emmanuel, thank you very much. That's always appreciated. Like I said, no one has to donate at all. It's honestly, I do this for free. Yes, I am. As Gemma says, I am an influencer right now. So yeah, morning. Hi guys. So there we go. If the bot is not going to do it, I'll make a big deal of it. So it's always appreciated, these donations. Like I said though, I'm here to provide value for you guys in any way it's possible. And everyone's job in this chat is to just have fun, whatever that may be. Assuming that you're following the rules, obviously. Right. Okay. Yeah, you're expecting that to... Yeah, Z standard. Is that from the Z lib? I didn't quite understand the compression. Anyway, so I've been rewriting everything. Nigerian. Oh, you're from Nigeria. Oh, that's really cool. Yeah, appreciate that. Honestly, it's I'm glad you enjoy the streams enough that you would donate. So it's $0.2 just to test. It's, you know, it's here's the deal, right? I think, okay, sorry to talk about this a little bit. I think I've already mentioned this on stream. I will definitely get this working next time. I think doing it live now would be it would take too long. But I don't mind if, like, I would do this for free, right? So that's the first thing. The second thing is, if people do donate to me, I don't mind, even if it's like one bean, you know. If you somehow you know, sent me something that was, I very much appreciate it, no matter what it is, right? It's honestly very much appreciated. Hi, coding Jesus wife. How to become an expert? Great video, loved it, man. I appreciate that, honestly, a ton. Thank you for enjoying. Thank you for watching it, and I'm glad you enjoyed it and got something out of it. So yeah, I don't mind, you know. So if the currency conversion is, you know, weak or something like that, it's totally fine. I honestly very much appreciate anything that I get. So yeah, big up you guys. I've been using LZ4, which is crazy fast to decompress, but doesn't compress it super fast, super well. Interesting. So what are you going to stick with, I wonder? The Z standard is a compression algorithm developed by Facebook. I see. Right. Okay. I didn't know that. Thank you for explaining. Right. Okay. So, you know, it's all appreciated. I'll eventually get this all working. I promise. I'll even donate to myself, perhaps. Who knows? Anyway, to test it out. Right. Let's get into it. So I've been doing a bunch of refactoring off stream. I realized that having a generic 2D renderer was oh my goodness, thank you, flippin' heck. Yeah, unfortunately I feel bad now that I didn't get this working with all these lovely donations coming through. Honestly, thank you for the PNL, 20 PNL. Again, I would try to get it working, but again, I'll just make a big deal of it. Again, thank you for that lovely donation. It's all very much appreciated. Thank you so much. Unfortunately, this I wish it did work, because I thought I set it up right, but for some reason it's just not behaving. Oh well. But again, I'll get this 100% working on, maybe I need to do this, I don't know. No, that's alert delay, really. Is there a way to turn this on? But anyway, I don't want to turn this into a get donation stream to test something out. So yes, like I said, it's all lovely though. Honestly, it's very flattering. Right. Okay. So what are we doing today? Right. I've been refactoring everything off stream. Not crazy though. I've just been splitting up the 2D renderer. So let's explain what we've been doing. Now we've got people here. I thought it might be a minimum value, but nope. Focus on the programming. No problem. Merci. It's yeah. I'll even give you yeah. Yeah, I'm extremely flattered. Honestly, it's so lovely that you guys are here for this. Despite being such a small streamer. And honestly, sometimes feeling like I'm not a very good programmer. You know, everyone comes in and be such a wonderful community. I'm so lucky that you guys are like this. I think I'll mention this real quick, but I used to when I first started streaming, I thought I would just get a ton of hate for no reason. So no, I literally got the opposite, which is, you know, super nice. And anyway, right. So we have a 2D renderer, which you already know about this, right? This is the sprite sheet thing. We have a standard sprite sheet 2D renderer, which is, you know, how we display this thing, which you've seen before, for a basic, an extremely basic UI, right? Now, originally I had all my kind of particle code and my 2D rendering code that would do sprite sheets, you know, stuff in like the same shader. This was to try and reduce how many graphics pipelines I would have. But I eventually found that the particle code was immediately getting more complicated. There was more and more stuff that I was having to add, and the amount of buffers that I was having to add, including the other stuff from the 2D render. Oh my goodness, thank you, Jared. What the heck? Yeah, you don't have to donate, Jamet. No one has to donate, honestly. It's very much appreciated, though. Thank you so much. Very much for those £2. You're too kind, honestly. Oh, I'm extremely grateful. So yeah, there we go. Thank you, Gemma. Again, I'll post it on the screen so you can see it for yourselves. There we go. Look at that. Lovely, lovely, generous donation there. Curse you, bot, for not working. Honestly, it's really nice. Thank you so much. The support goes a long way for like motivation and stuff, so it's always appreciated. No, but like I said, everyone's job here is to kick back and relax and have a good time. So, you know. Right. Okay. So, right. What was I? I had these like two buffers that were kind of being used as a buffer device address access thing, and it was just getting like more and more stuff. I would have to have like the structs were getting like incredibly dense. Like there was a lot of like extra data in here that was kind of supposed to do something else. And now so we have a particle set here. So effectively, the way I'm structuring my particle system at the moment is I have a particle, right? But that is belonging to a particle set. This is going to allow us to do things like have a load of dust on the screen, for example, right? That would be one particle set. And then you crash into a rock, and the rock explodes or something. That would be another particle set, right? So this is the idea. We group particles together based on their set. So we have a way to index into that with a index here. So we have a particle data, which is this is the actual particle itself. And for those who don't know, because I know not everyone's like necessarily a programmer here, when I say a particle, just for those who don't know, a particle is just a small object that gets rendered. It's typically 2D. So you can think of it like parts of an explosion, dust, things like that in video games, right? Bullets are sometimes particles, not always, but most of the time they are. Gravel, all these type of things that exist in games that aren't necessarily a model, that get generated by the actual computer code, right? That is a particle. So they are small little things, almost like I would say the dandruff, I guess, would be a particle, right? Things like that, right? That are they all do different things, and sparks would be a big one that you see in video games. Maybe not dandruff. So yes, we need to like group these particles via the sets. And yeah, admittedly, I'm a bit flustered after all those lovely donations. Anyway, we have a particle renderer, and here it's effectively a mirror of the 2D renderer, but it has a few differences. The particle set code is going to be so we're going to generate a buffer for the shader, which is a particle set buffer. Now I've decided to make this a CPU side buffer because it'll be easier to update, and that's fine. But for now, we're not going to update it at runtime, so it's going to be safe to have one of these guys. For those who are like learning graphics programming for the first time, right? We have this idea where we have CPU side buffers need to be updated per frame, right? But if it's at load time, where your frames aren't actually accessing the CPU, so like for example this buffer, if I wanted to add a particle set at runtime, we would have to make sure that we update this. Gotta support the go. Thank you. Angela Cutie, hey, hi. Good to see you again. So we don't have to worry about that. Yeah, it's honestly very much appreciated. Thank you, Gemma. Why are you getting so much money? Goddamn money. Well, I don't know. I just think people are being very kind, which is lovely. Right. Okay. So we have a particle set. That's there. The problem is though, let's just have a run of the code. After this refactor, we should see a blue particle like we used to, and we don't. So the first thing that we're going to actually do is throw this into RenderDoc to see where the mistake is. Currently, we should see a particle about about 8 units up. So about here, right where I'm from the dock. The dock is like 0, 0, so that's a good like reference point. So yeah, I'm gonna throw this into RenderDoc, and we're gonna investigate. Got to go now. Have another football game. Well, good luck on your footy game, man. Hopefully you have a good go. I'm gonna donate 500 if you guys keep taking away my number one. We're testing the donation notifications cap out. Yeah. Yeah, it's one of them. I wish I knew how it worked. I thought I got it working, but there we go. Anyway, so we have let's throw this into RenderDoc. So we have, so for those again who don't know what RenderDoc is, I will just explain this just again. RenderDoc is a debugging tool for debugging graphics. So the downside though is you really can't have any validation running at the same time, because what ends up happening is the commands in Vulkan anyway are layered. Sorry, there's layering. There's this concept of layering in Vulkan. This is something that's quite basic, but I think I'll explain it anyway. And basically, you can set up this thing in the middle of the graphics driver and your code as a validation layer where it checks to see if your code is correct. Now, this works in the same way for RenderDoc. RenderDoc will try to do the same thing. It will try to sit there between my calls and intercept them and then replay them. So the other thing I need to do is make sure. So that's how we're able to debug things. It's able to figure out basically the state of the program and what the GPU is doing, because it's harder to, obviously you can't put a breakpoint on a GPU, right? Set up a Ko-fi because YouTube only gives the decimals. Yeah, people have been saying that in real life, that I should set something up, but without getting into too much detail, I almost feel like I need to do better before I can do that. I don't know. It's like I get in my own head about it. I don't want to when it comes to like Patreon or Coffee or all those type of donation apps, I don't want to be like I don't know how to explain it, but yeah, I don't want to be that. I don't know. I almost feel like I don't deserve it, if that makes sense. Right. Okay, hang on. Let me get rid of this. And I've just realized every time I regenerate the project, the CMake is copying over stuff that I don't want it to copy over anymore. So this is I think. Yes. Okay. So I need to get rid of this. I realized recently that this is like gigs and gigs and gigs of stuff, because I've just been like slowly adding more and more models throughout the days. You can't put a breakpoint on the CPU in the same ways, because there isn't a like program counter that I think that we can follow. Maybe there is maybe in the future there might be a debugging tool that allows you to break through. Also, there's lots of little programs that run on a CPU, sorry, on the GPU. Actually, I don't know about the program counter thing. I'm gonna take myself back on that. So maybe in the chat, someone could say like, yes, the thing has a program counter. Anyway, but on the GPU, I do know this for sure, that the GPU has different programs that run, right. So we have a vertex shader which runs for every vertex. Now, if we were to put a breakpoint in the GPU, we would need to do it per shader, otherwise it doesn't really make sense. You can kind of do that in RenderDoc. You can like rerun the shaders, but that's not quite the same. That's not quite exactly what we're talking about here. So what I'm going to do actually is go back to our source directory. So yeah, I've realized that I've been I've tried to get rid of these, and then I've realized that I've kind of left them lying around. So I'm just going to go back into like this, delete these, and then put these in, which will just be the regular stuff. And then I can surely, let's just make sure this runs now. I've done that. Okay, so we are missing something, which is fine. Let's go back to debug real quick. We should be able to see what that is without any issue. And then we'll be able to debug this a bit better. I think we're just missing something. Be a little selfish. Yeah, Angelica is a cutie. Now, if people want to help, let them. If you don't have money, if you don't have the money, they won't. Your dedication to good content deserves to make money if it can. Yeah. Yeah, it's appreciate that actually. Oh, we're missing some of the audio. Looks like I've deleted that, which is easy to get back. What are we missing now? What audio? Yeah, so we've managed to wipe out too much stuff. What do we want here? We've got three different things. Laser. Okay, I don't know. Hang on. What do we have here? We have flying noise. Oh, we don't have laser.flak. Okay, so let's get that. I think that'll be in the debug. Audio. Interesting that we're missing that. So I'm just going to put that back in the source. Sorry about the bit of a faff. I didn't realize how much stuff I was missing. Yeah, that's generally generally like, yeah. I don't know. Maybe I'm just getting in my own head too much. I just want to. I am a bit of a warrior, I have to admit. When it comes to stuff. But yeah, like I said, my main priority is making sure that you guys have a good time. Damn, my British pound is more expensive than the euro. Yes, it's one of the strongest currencies. I won't go into it, but it has caused some issues for trade. The UK struggles to export anything because the currency is too high. But the financial industry likes it being high. So we've now got a super advanced financial system, and like everything else kind of suffers. But yeah, I might be risking going to politics there, so I'll leave that discussion there. That's effectively what's our current state of our currencies in. Right, so that should... Hello, just watching. Thank you for joining us. Right, so let's see if the audio is back and everything kind of runs normally. Yes, okay, now we can throw this into render doc. And we should be all good. Let's just make sure this runs. Yeah, I hope everyone's having a good day, by the way. You know, I don't think I've said that, but yes. Okay, so now we can throw this into render doc. Render doc. Let's get that open. And we'll just get this done and at least get ourselves running. Oop. Password 123 to get up my thing. I don't know if you guys can actually see that. I do wonder if you can see that user account thing. Okay. At the end of the day, donations are for those who are willing to give. So if it can help / thank you, then why not? Yeah, that's a good way of putting it. Yeah, okay. I'll think about it more seriously. I think I get it in my own head. This is the it's like I'm not a big enough creator to do that, right? That's what I'm thinking in my head, right? I'm like, but you know, does really someone with X amount of things, or, you know, subscribers or whatever, should I be, you know, should I wait till I get to like a, you know, big enough that, you know, people go, okay, yeah, this is worth supporting because it's big enough or whatever. That's just like how that's why I get maybe I'm getting in my own way. Nah, just a black screen. I see. Thank you. All right, so let's go into render doc and give this a run. Let's turn off that to make it easier a little bit. So we should see something that we don't see. And what we're interested in here is, what is that indirect draw call seeing? So I hope that we can see at the very least we can see what we should be looking at here. So the scene data, let's make sure this makes sense. Yeah, that's roughly kind of what a view projection matrix looks like. There's nothing crazy going on here. And let's just make sure I got that multiplication correct, because that's something I can sometimes get wrong. Is project view, that's correct. Not view project. Let's kick off the music again. What is this? Are you familiar with RenderDoc? Just watching, I can explain it if you're unfamiliar. If not, I can explain kind of what I'm trying to do here. So the transform. So this is the particle set. So what I'm looking for is I'm looking for an error in this code where I see kind of like something going wrong. If nothing is wrong, then I'm going to suspect it's the texture. If something is wrong, yeah, please explain. Okay, so this is RenderDoc. If you're debugging or wanting to do anything with graphics, this tool is super necessary. It's honestly one of the best tools. It's so good at debugging that I recommend, if you're stuck and you don't understand why something graphically is going wrong, then I recommend like throwing something into RenderDoc. What it does is it intercepts your draw commands before it hits the graphics driver, and it kind of records them and then replays them. So for example, it can do this, right? So you know, it can see the textures, it can see what we're rendering, but if I go to like here, for example, and then step through, you can see it's like building up the textures. So why I'm doing this, right, is because I should be seeing something. I should be seeing, yes, RenderDoc, yes, that's what it's called. I should be seeing like a little blue dot up just above the dock here, but I'm not, right? So this is interesting. And it's hard to debug this on the CPU side. Because there's no way of going, oh, breakpoint in the code. You know, I can't go like, I can't really do this. This doesn't exist. I can't be like, oh, evaluate what this means here. This doesn't work. And even if I was to go into the C++ code and be like, okay, so in the draw, breakpoint there. Because the CPU and the GPU are basically different computers, they're almost like doing different things. So, yes, getting the CPU side is important, but we'll really see the errors that come about because we can investigate what RenderDoc has recorded. And a couple of things that are really useful to know is what I use it mostly for is to check out my buffers. My buffers sometimes are all wrong. As you can see here, we have a bunch of data in here, up to 10 for some reason. Oh, that's because I've allocated. This is because I've allocated 10. And we do have the positional data, right? So this shows me that this buffer, that's a view projection matrix, looks kind of regular. This has data in it. It's kind of chilling, it looks like, from what I can see. This will have more data in eventually. Nothing seems to be out of the ordinary. What I'm looking for here, this is something to check. How I do this, by the way, is I go to, just so you're aware, you know, I can't see, this is the draw call that should be doing the little particle. I go in here, then I go to pipeline, vertex shader, because that's where this is where it should be transforming the data. Then I can go down here and check out my buffers, click on the buffer, right? And then I can see the data. I'm looking for bad data. All the data is good though, so that just tells me that it's likely something to do with the texture. Yes, it's cross-platform. So it should run on I can't even say it, Ubuntu. I love how you always explain RenderDoc is even when not needed. It's like Danny with Carlson or whatever. I don't know. Do you mean Danny, that developer? Yeah. So yeah, give RenderDoc a try if you ever get stuck on some debugging things, because this recording of commands is super insightful a lot of the time. Yeah, no problem. Thanks for asking questions. It's part of the reason why I'm here today. So you know, feel free to ask more if you are confused or you're not sure what's going on. Yeah, because I want for the people who are, I want people, I would like for the people who are interested to understand what's happening, so you also can become a good graphics engineer, or at least get to my level, right? And maybe surpass me, who knows. Anyway, so I'm suspecting that everything's right, but the texture is flipped again because that is causing issues. So what I'm going to do here is just load the debug texture that I have for this particular case, which is oh, thank you for the jewels. Thank you so much. So this is what I was trying to set up things for. Yeah. But yes, thank you for that. Again, I'll make a deal out of it. There we go. We saw it there. Thank you so much for that. For the potty hats. That's very nice of you. Thank you again. Oh, thank you so much, honestly, for supporting this stream. It's all very nice of you. Yeah, RenderDoc is pretty goated. Right. Okay. So what do we want to do here? We want to check out textures. Yes, I'm just going to look at my textures. Where are they? Build, assets, textures. Yes. Okay, so I'm going to look at this. This is my debug texture that tells me which way round things are. It's pretty ugly on purpose. There we go. Got yes, the number one medals there, gold medals all around. Alright, cool. Oh, yes. The other thing, what is it? So, are you talking about the jewels, or what are we doing this debug texture for? Yeah, because YouTube has added this thing, I think, to vertical, like, phone live streams, if you're interested in the... No, okay, interesting. So I thought we would see it. Right, I'm just going to make sure it's not inside this rock real quick. No, it shouldn't be, but... no, okay. So, yes, and I think they've been added, like, literally a couple of days ago to, like, regular live streams. And it's a way of supporting people, I think. I'm very new to this as well. It's like... You buy a bunch of, I think, jewels, and then you buy a, like, with those jewels you can buy, like, an emoji, I think, and then that can translate to supporting the creator that you're interested in. So there we go, there we go. Sent, yeah, so just watching is sent 6-7 for 6-7 jewels. Thank you so much. Yeah, so there we go. Very nice. Again, I'll point out here so we can see it. Lovely. That's very nice. Hi, Monchi. How you doing, dude? So yeah, honestly, thank you for that. So that's what it is. What we're doing here with the texture, anyway, is we're trying to see if we can see the... yeah. They knew what they were doing with that one, 6-7. I have like an ugly looking texture that kind of tells me where I am in the sprite sheet. So if I'm like in the wrong place, I'll be able to see like, oh, I'm in the white area and I should be over here, or I'm in this squiggly green area and I should be over here. So this is like a nice little debug texture. Yeah, the emoji thing. So yeah, that's what I explained, the emoji thing. It's like kind of like a way to... The emojis that are coming up in the chat are like, yeah, like a way to support the creator. So hopefully that makes sense. Thanks for just watching. It's always appreciated you being so kind. Right, okay, so for some reason we're not seeing anything, which is kind of tricky. Right. So, what I'm going to do is, I think I'm going to simplify the particle shader, because I think... Oh, there we go, yeah, that's it. Sent a chili, thank you, Gemma, for that lovely... I believe, lovely donation. Thank you. There we go. Another one I'll show on screen. Yeah, I don't know what that... but you can't send a seaside one. But anyway, let's... thank you so much, Gemma. That's really, really nice of you. I don't even know how you end up buying them. I turned them on because YouTube said I could turn them on. I didn't really know what it meant, but there we go. after a bit of research, that seems to be what it is. It's a translation from... I think they're trying to copy what TikTok did with their live streams. That's what I think that's what's happening anyway. Anyway, so we have the instance count here. What I'm going to do is just kind of set up some data here. I have a feeling that we're not getting the right thing. This should be 0. And I don't know if it's like an undefined value or something, so I'm just going to kind of put these in here like that. So yeah, we're just going to like mess around with the shader. And see if we see something. So no, nothing of late. So if I put this at 0 and 0, what do we get next? Now I've also got to do a sanity check. So I'm going to move back to debug now. A sanity check is always good to do if you're a programmer. Challenge your assumptions. Oh, you got 50 for free. Nice. There you go. There you go. You got 50 for free. Yeah, probably because it's new. Yeah, that's probably right. I don't know what the currency exchange rate is for these things either. I have no idea. One rupee is equal to 1 cent, like American cent. I don't know what that means. Apparently, because you don't give me money directly, you give me a rupee. It's all a bit confusing, to be honest. It's like you buy jewels, you get an emoji, and then it gives me a rupee, and then that changes to money somehow. Either way, it's long story short, you shouldn't have to worry about it. It supports the stream, so it's all very nice. No matter how it's done. There you go. Yeah, the music around you, 9cat. Indeed, I do like that type of music. This game is from my childhood. This one. I don't know what it is. It's like it's not Indian rupees. It's I don't know. It's just like it's a bit confusing, to be honest. But let's move on from there. What currency it is. Either way, long story short, it's all very much appreciated, and it does help the stream. So thank you so much for that. Anyways, oh, there we go. Thank you for the tool. Thank you for the sparkles. It's very nice. And 2. Wow, thank you. Thank you, Gemma. There we go. That's all very, again, I'll show it on screen. Very nice. Thank you, Frankie. That's all very lovely. You know, again, no one has to donate. It's all just, okay, so, but yeah, it's all very lovely things. Right. We have, nothing rendering, and I'm kind of confused, honestly. Because we should have a position. Okay, let's get rid of the position. We don't actually need this. Now, the next thing is to figure out is the world position make any sense? Gems convert to your local currency weekly or monthly after YouTube's cut. I see. Okay, that makes sense. Thank you, just watching. I think we're not going to get any difference here, as far as I can tell. No. Okay, so something is wrong with something else then. I think nothing's gone wrong. I'm going to leave this all at 0. I can easily change this back. Now I'm starting to think, okay, is the positions, are these good? They come from here though, so I don't think they should be affected. I don't know. RenderDoc has told us that all the buffers make sense. We have enough size for 10 particles. We have... what else do we have here? So we have... I don't see anything wrong, really. I mean, what I could do is just check the view projection matrix is good. Just be a bit careful here. That's quite easy to do. Because all I have to do is relaunch the application and not move the camera and just see what it is, right? Because it's easier to see. Right, so I'm just going to capture that. Although we shouldn't see... we just see the dock in the bottom corner. But we should hopefully see that this makes sense at the very least. So I've got a pipeline stage. So we have particle set. No, we had the scene one, sorry. Okay, so yeah, that's reasonable. I don't know what the Z division should be by default, but generally speaking, this is kind of like a standard. I haven't moved the camera. It's translated by -2, -2, -2 instead of 0, 0, 0, and that's basically it. That's the only difference, really. But yeah, we have a view matrix, which is just an identity with the translation, and the rest is the perspective divide, which is, you know, allowing things to get smaller as they get further away. So that's actually fine. And again, I'll just, for completion's sake, go over this and this. Okay, so now we just need to work out we need to go backwards. In fact, I'm going to actually remove the idea of textures altogether, which I can do, which it will break the main menu. How do they even give you a cut? That stuff's sense. Let's just take it all. Adios, people, for real this time. All right, Emmanuel. See you. Yeah, good luck with your footy game. I hope you do really well. So what I'm gonna do? Well, I don't know the machinations of YouTube, to be honest. I'm still kind of. I know, despite nearly streaming 100 times, I still don't really know what's going on. Vec4 1.f 0.f 1.f 1.f. Okay, so we're just going to set everything to a color. This is going to remove the texture, so the main menu is going to break on purpose, but that's also going to remove any... Okay, so that rock might be literally right where the particle is for real this time. And when we go inside the rock, no. And let's just run this one more time. So these rocks are randomly generated, so that's why I'm rerunning it again. Nope. We should see a rectangle. Sorry, a square, really. Excuse me. Okay, let's just make sure that we're setting everything up properly. I did do a big refactor, so it's possible that I'm missing something, like load buffers or something like that. I don't know. But I believe this is a pretty simple, as far as I'm aware anyway, it's pretty straightforward. There isn't anything... let's see. So we have in GPU... And we basically say add particles, we load the buffers, which is basically just creating these fellas. So they do exist, they definitely have something in them. And we have a texture here that should, well, we're kind of ignoring that at the moment. I don't really know. Yeah, this shouldn't be called button size, to be honest. This should be, yeah, let me just think for a minute. I believe these... Yeah, what I'm going to do, actually, is the I'm just going to 256 by 256. That's going to at least make the wideness of this. I don't know why this is not rendering. It's very strange. The other thing I actually should do is remove everything from the scene. Hi, Vulkan. Thank you for joining us, and thank you for the reactions as well. Anyone who... I can't see who's doing that, but yeah, it's very much appreciated. Hopefully you're having a good day, Falcon. So, let's see... Again, I've just turned off textures. Any luck? No. Okay, so let's keep going. I'm just making sure that we're not doing something we aren't supposed to. Right, next. Right, what have I missed? I've made a mistake somewhere. Cull mode is off, so we're not culling the back face of the geometry. We have two different shaders which are doing We have one fragment shader because it's the same thing. We have the particle shader. And what else? We add a descriptor set, which is the bindless stuff. That just allows us to have bindless textures. Very common nowadays in renderers. Okay, so the sprite offset is, yep, 1, 1. I don't know. I'm trying to figure out what could be possibly wrong. So the next thing I'm going to do is just disable everything in the scene. So we're going to go into our main code and basically remove all the graphics apart from the particle that should be rendering. We should see just gray. It kind of looks lame. Actually, at the very least, no. I want to do this just once, and then I'll turn on the skybox probably only. The reason I want to do this is I want to make sure that it's not being rendered behind something, like the skybox, for example. So yeah, we should see something, but obviously a big gray square is really difficult to see in 3D, so I'm going to just redraw the skybox in, and that's just going to make sure that it should be rendered first. So we should see, yes, we should see the skybox. I'm just going to do this for now. This is going to be the simplest. Right. Okay, so let's turn on the error checking again. I should turn that on in debug. Right. Okay, so interesting. Maybe I should get rid of the particle stuff and just see if I can render a rectangle. Like, without any of this stuff in it. If you know what I mean, right? So, instead of actually doing the billboard, maybe it's best to, yeah, let's just do that then, and just check if it's not the position itself. So that's not going to face the camera now. Which is obviously what we want for particles, but you know, as we debug, we've got to peel back layers so we can get further. We can figure out what this error is of things not rendering, which could be a couple of different issues. Okay, we've got a compilation error, which I don't think is going to be too difficult to find. Oh, right. Have I turned on something and not turned on? Yep. Okay, so I tried to turn on logging and not the validation layers, which is not a smart move. All right. Nope, I don't see a single rectangle anywhere, which is interesting. Okay, so we don't see anything at all. Right. And the data in the shade looks fine. What is happening? Okay, so let's put this at 0, 0, get rid of this. Oh no. It will definitely be at 0, 0 now. It is project view. I'm just going to confirm that for real this time. Project view. Yes. And I don't really see... Oh, I should get rid of this. Leave it running unnecessarily. Okay. What have we got next? So we're not doing any of this now. We can almost comment it out because it's completely worthless. We're not doing any textures. We're not doing any coloring. We're not doing any text chords because we've disabled that in the fragment shader. We're not doing this particle set anymore. We're literally just... We're not doing anything with the text chords. So, as far as I can tell, we've simplified the shader to the point at which nothing apart from the actual GL position of a rectangle, of a square, I should say, is being affected by the view projection matrix. So, and this should be updating every single frame. I could, yeah, let me change something real quick. I didn't feel the need to do this, but it might be an issue. I'm not sure. We have this being updated basically once every single frame. Now, originally I had set the data here, but maybe to do this properly, I kind of need to set the data up beforehand. And the problem is with this, though, it needs to kind of have something in it. So I'm going to kind of fake it for now. If this doesn't change anything, I'll actually use the perspective and the view. But what I'm trying to avoid here is just hassle and unnecessary computation, right? So I'm going to see if I can get away with just setting 2 matrices to the identity. And for those who don't know much about maths, an identity matrix is effectively setting something to 1. Now, if you think about the number 1, if you multiply something by number 1, it stays the same, right? You know, 1 times 500 is 500. Surprising no one. So that's an identity, right? If I have 0 and I multiply that by 500, well then it's not 500 anymore, it's 0. So it changes the value, meaning that and a matrix is kind of just a more complicated way of doing exactly the same thing that we do with numbers. So we need a way to define a single value that when multiplied by another matrix, that it returns the original matrix that we multiplied it by. So effectively an identity matrix is 1, the number 1. No gain, there's always an Asian better than us. Yes, especially when it comes to piano. I feel like they've got a monopoly on that, haven't they? Thank you for joining us, by the way. And no, I don't think that changed anything at all. In maths, identity is always a neutral value. 0 for plus, 1 for multiplication. Yeah, that makes sense. Okay, that's true. I'm only talking about multiplications, I should say. Oh, yeah, the pink is... I'm looking for a pink square in the scene when I've got the skybox rendered, but sadly nothing seems to be turning up, which is unfortunate. And I don't know why. This makes sense, to be honest, that nothing really changed, because the render doc code looks normal. I mean, I could, like I said, make it the view. I could make a view projection matrix, but it's kind of a faff because there's a lot of arguments into this, because it has to do a field of view based on, you know, some values. No, it needs to use the aspect ratio to build up the matrix. I kind of want to avoid that. Yeah, it's hiding behind a gas cloud. I really wish I would see it though. Unfortunately, that gas cloud is infinitely far away. So we would never actually get behind it. Because that'd be how skyboxes work. But it's also a good way to represent like direction, so we can see what we're doing. What is your graphics card? Yes, let me type in a command for you in the chat. And if the bot is working, that should give me my whole PC spec. So I've got like a decent graphics card. It's the last one there. It should be not GR Force. It's definitely GeForce. But yeah, that's what I'm rolling with. Yeah, 5 billion light years across, exactly. Well, skyboxes are actually kind of tricky. I'm actually rendering a 1x1 cube on top of the player. And as soon as you move, the cube comes with you. It just feels far away because it has no depth. And I don't... Do I translate it, actually? That's a lie, I think. But anyway, I can't quite remember. I don't think you translate it, actually. Anyway, yeah, effectively, yeah, I keep looking at that. So there's multiple things that I could improve about this spec message. GearForce. But yeah, you don't have to have like a good graphics card to run what I'm trying to run at the moment. If right. Oh, thank you for the 10 jewels. That's so nice of you. Thank you, Gemma. Again, I'll just show that on the screen because the bot is broken. But yes, there we go. Lovely. There he goes. Thank you very much. Yeah. Oh no! Don't try and get me. Unfortunately, they're for an older CPU, so they're not that good. I think it's 29,000K read-write speed or something. So the read-write speed is really slow because the Intel i7 87,000K, or what is it? No, 8,700K is actually quite an old CPU, and you can't just randomly slot in some. Yeah, I think it's also DDR4 my RAM. It's not DDR5. So yeah, it's unfortunate. Despite it being a big number, it's older in different ways, which makes it not as desirable. Which is why I got it kind of relatively cheap in comparison to like new DDR RAM. Right. So, but yeah, despite that, I'm sure the AI people try and take it off me anyway. Yeah, it's fine. Yeah, I don't see its read-write speed has never become an issue, to be honest. But yeah, it's not as good as you would imagine. Basically, it's not like I've got bleeding edge RAM. That's 64 gigs. Right. Draw particles. So indirect count, indirect handle. Yeah, everything seems fine, which is kind of confusing me. If I do 2 draw calls, what does that do? Does that do anything? I don't know what's gonna. That's the max draw call count that can possibly happen. I don't think it's gonna cause any issues. Oh, God, maybe it is. Interesting. Okay, it's just saying I think the buffer is too small, which makes sense because I've only set it to 1. Size of 1, which is yeah, it's telling me the maths is all wrong. It's this buffer, right? It's too small. This buffer's too small. Yeah, that's it. Most people are after DDR5 RAM when it comes to what they're but unfortunately, as you're probably all familiar with, Sam Altman has decided to buy 60% of the world's RAM. But there we go. It is what it is. Okay, so what am I making? I'm making a mistake here and I don't know why. How can I simplify this anymore? Let's think. We can get rid of the view matrix, I think. Actually, let's get rid of both. If we get rid of both, that should be a rectangle just stuck on the screen, like right in the middle. Because there's no perspective divide, so it should just sit there right in the middle. Which IDE is this? Yeah, it's Visual Studios. It's pretty good for C# and C++. It's not really used for much else. No, it's just not here at all. Okay, so no matter what I do, the data is just not here. And okay, so now I've got to think about this. If the data is not here, what on earth could be wrong? So yeah, most people use Visual Studio Code if they're going to use this at all, but this has like It's more of a full-on IDE, whereas like Visual Studio Code is typically used more as a text editor. I mean, you can debug stuff in it, but this is really designed to like check your memory. It does like it can do other stuff. How can you buy all the RAM? I don't know. There we go. I think I got lucky. I think I got it before Sam Altman decided to buy up all the RAM. Oh, how can Sam Altman do that? Oh, if you're asking that question. Just say US politics and economy. I'll just leave it at that. Cubes right behind you. Yeah, that's sort of, yeah. I thought it was the chips and you put the chips in the computer. Yeah, that's what RAM is. Yeah, it's called a RAM stick if you ever see one online. But yeah, people are buying those RAM sticks that you can slot into your motherboard. I've gone super expensive. That's what it is anyway. It's like oh, Cube's right behind me right now. I see you. I should look behind me. Yeah, I did look. Unfortunately, the cube is not behind my head, sadly. Unless it's inside my head because of depth testing issues. Alright, so is okay, so what I'm going to do, I think, is just make it the simplest shader that I can possibly make. But I've already done that. I don't really understand how much simpler I can make this. I think what I'm going to have to do, I know I keep saying think a lot, is increase the amount of instances, I think. Yeah, that's what I'm going to do. Okay, so I'm going to bring this back in. Because I want to see if I do this, nothing's going to change. Hey, the big loose goose. How you doing, dude? Doing a bit of debugging right now. We're trying to figure out why we can't see a lovely rectangle in the world. Okay, so what I'm going to do is I'm going to, because it might be a buffer out of bounds read, or out of bounds buff. What is it called? OBB. Out of bounds buffer. Yeah, out of bounds buffer read, right? Or right, depending on what the issue is. The only way to really test that is increasing the amount of things that you try to read, otherwise the validation won't pick it up. Meaning that in my compute shader, where I fill up everything that I need to do something like this, where I kind of, again, this would be done differently, but this is mostly for debugging reasons. So I'm just going to set 5 values. And we're going to set a draw call to have... This is roughly enough data for the validation layers to pick up my mistake. If I've made that type of mistake. I'll do 5 just to be sure. I've got... the buffer should be twice as small. So if I do... I'll just do -1 each time. -2. 4... 2, 0, and then -2, I guess. So that should be a row from top to bottom. And we have, what, 0 to 5, so we have 6. And now we need 6 things here. And let's just see how that behaves. No, still nothing. Which is peculiar, because this worked with the old shader, right? I mean, I could git stash and kind of work backwards very carefully. That might be a way forward, but it just seems like a waste of effort. But at this point, I'm starting to lose hope a little bit. I wanted to ask you something. There are resources on computer graphics, but where can I learn some good game engine design and game code design in general? I would stay away from patterns. That's like the temptation. There's something called patterns online, and that locks you into an object-oriented mindset. What I would look for, game design. So this is unfortunately like where there aren't really strict resources for this, because it's not really a science, it's more of an art. Meaning that many people have their opinions, and many people are right in many certain circumstances, but not always. And this means it's kind of difficult to study, right? Like, what do you need to study to get better at this? It's kind of not clear. So I would say something like study data-oriented design, right? Because that is going to be like how you have good cache locality for your engine, right? But also, I think the game engine architecture book is a good gives you a general idea of what's going on, of like what's going across the engine. Okay, the compute. I think that's like that'll tell you all the pieces that are moving together. Not game design, sorry, yeah, C++. Yeah, I understand what you meant. C++ code design. Yeah, I feel like patterns are something that people suggest, but I don't think it's they're that useful, to be honest. For game programming, anyway. So yeah, look into data-oriented design. I feel like that's, again, this is a bit of an art to like get good at this stuff. It is a little confusing. Another thing that you could do, honestly, is look at other people's engines. Like, if you look at, say, I don't know, I assume you want to do a, graphics and stuff like that, right? And like game engine development and stuff. So if you look at those like engines that are considered good by, if you're not sure, just ask. Like a good project. Like look online for that kind of stuff, and then like take notes on like what you like about it and what you don't like. And this is another opinion. Feel free to discard this or disagree with me. I think entity component systems are overhyped. I really don't think that that's necessary. And some people will say that they're the be-all and end-all of game engine development. But I think you can overkill. You can do it. You can completely overkill your engine if you do that, right? So I highly recommend, if you're interested in this kind of stuff, is to take it from an engineering point of view. Try not to fall into the different zealot camps, which would include even data-oriented design, for example. And kind of like what I like to do anyway is like take what I need. What do I need to know? What do I need to know? What's necessary for me to learn and get better at this kind of stuff? And if that is data-oriented design, then it's data-oriented design. If it's not data-oriented design, then I don't learn that stuff, right? What you should be after when it comes to this kind of stuff is writing the least amount of code to do the maximum amount of work. Whoa. Okay, so we got that guy back, and I believe this is the old system. So yes, so that's what I would do. I would tackle it like that. Tackle it as an engineer, the big loose goose. Avoid the holy wars, and use the resources like game engine architecture and data-oriented design resources to develop kind of like more understanding, and take notes on other people's engines that you kind of like. And yeah, just unfortunately some of this stuff has to be learned through experience. So yeah, that's my general advice. Yeah, obviously writing code, as you get better, you'll be able to write better code. So this will eventually start to become easier, eventually, but not overnight, right? So when I go oops. So when I do this, I remember this not working. Okay, so what we're going to do, we're going to do this very carefully. What I'm going to do, actually, is literally swap in my... Oh, there's so much work that I just get stashed, which is annoying. But I've got to go slower. I've changed too much too quickly. Yeah, basically be open-minded while being centered on what I actually need. 100%. Because no matter who you ask online, this is one of the most debated things on the internet when it comes to programming outside of something like AI, is like, what's the best architecture? And because there's no like best answer and it's all situational, people have super strong opinions that they say that this works for them 100% of the time. But yeah, if you keep an open mind and just realize that, yeah, you should be fine. But yeah, good resources, like I said. If you type data-oriented design on YouTube, there's really good lectures on there. I think there is a data-oriented design book, which I haven't read. You get all this for free with, what, are you talking about Haskell? Angelica is a cutie. Lol, writing at ATM of code. Guess the maximum number of jar gets. You should do arrays of structures directly, not ECS. Yes. That's what I would like. I would use, yes, arrays of structures. Yeah. Well, Haskell has its ups and downs, and that's probably one of its benefits. But yes, this is one of the things that, for example, if I say, oh, you shouldn't use Haskell because game developers don't use Haskell, that would be a dogmatic point of view. But also saying that just use Haskell, it'll solve all your problems, is also a dogmatic point of view, right? I'm not saying that you're saying that, Angelica is a cutie. I'm just using that as an example of like how to stay open-minded and pick the things that you actually need to do for your specific case and learn that, which isn't always easy to do because a lot, you know, what is the thing that you should do, right? Anyway, it's kind of tricky, so I understand it. Anyways, so what I want to do is run this code. We see that, which is fine. I've edited this, right? Did I edit this? How do I want to do this? Because this is, I just want to do, okay, so let's, oh, this is going to take so much finesse to get right. Because I don't know what's gone wrong and I can't figure it out. So what I'm trying to figure out here, let me think for a bit. What I'm trying to do here is I'm trying to incrementally do the changes that I did over the git stash, right? The problem is right now, I don't know what it is that I'm trying to do. Let me think for a bit. So obviously it would be very nice just to throw in a get rid of the main menu. I think that's going to complicate things for a minute. So I'm just going to assume that I want a particle renderer. So we're just going to get rid of this. And we're going to try and change the 2D renderer into a particle renderer only. And see if, you know, where the mistakes come about. So, unfortunately that might break. Okay, so that's still there. But we'll see. Yeah, a lot of things it's advertised to as kind of disable. You get both the benefits of language and functional while getting the benefits of like using any other language. I was tempted to ask AI for tips regarding design, but I think it would set up the long. Yes, I 100% agree with that. You've got to remember that the big loose goose, a lot of that LLMs can only tell you stuff that's already been out there on the internet. And so what you're going to get, unfortunately, is just an aggregate of basically what Reddit assumes is correct in 2019 or 20. You know, and that's going to be an amalgamation of every single language that exists from that era. And yeah, you want to be like super engineering focused with this. Like, what do I actually need to know? What do I actually need to do? How do I make things fast? How do I make things performant? So that should be the way you should think about the code. That's why I point you in data-oriented design, because that's what it cares about. It cares about performance. Whereas like other design patterns and stuff like that just kind of say this is saving development time, which I don't think it does, but this is kind of like where the holy wars kind of start. So I don't necessarily think that's true. And yeah, so because you want to be writing like fast code. Right, so I think this... Why are you being all weird? Oh yeah, because I stashed it. Got you, thank you, no problem. You know, it's a tough one to figure out. To me, I still don't feel like I'm there, but I remember being super frustrated by this particular issue. Yeah, okay, it's everything's chill. I was super annoyed by it. I was like, how do I just know how to architect my engine? I don't understand these things. And yeah, that's where I'd go. Like, you've also got like it's harder to find this, but like if you like Jonathan Blow, for example, and you respect his coding ability. So what I need to do here, then you can listen to what he thinks about things and then kind of follow that until you're more experienced. But that's kind of harder to do because it's like he rants and raves about a lot of different things. So if you follow everything he does, you'll be writing your own programming language. So it's kind of trickier, that one. Alright, so I'm just trying to make this to particle stuff at the moment, so we want this instead. Alright, so this is fine. So I'm going to have the padding in for this. Get rid of that. And particle data, this is fine. So I'm going to throw this all in one file so I can just kind of not do as much. I talked about him just now. You did, indeed. That's why you reminded me of him, yeah. But like I said, it's I'll keep scene data the same actually. It's one of these. You can end up following someone too far. And yeah. So we have this is not anything. And for each quad, what is interesting about this? Let's just try and do something different here. Okay, so I'm not gonna... Yeah, don't do what I'm doing here. This is gonna be a bit weird. But I'm actually... No, that's not gonna work. The problem is I start writing a lot of code here. It's just gonna be... I'm gonna have to delete it all. Let me just think for a minute and see if I can work this out. So we have the particle thing that has structs of data in which are different. It has this. That does exist. But then it has that. But that's kind of tricky to write. Ugh. What is going on? It's not frustrating. It's more like disappointing. Stash. Git stash drop. Git stash apply. Alright. The problem is I'm not really... Why is nothing rendering and render doc is telling me that everything's fine? Let's try again. Let's throw this into render doc and see if I can find something else. Yeah, I'm just going to do this, right? Oh, no, we need positions. So, like I said, we should see something at the very least. We should see 6 instance rendered things all in the same position. Because they're not even using this value. I got this working just the refactor didn't work. Ah, it's so disappointing. Alright, yeah, reload all, I guess. I don't know what it needs to do. I'm going to just rerun this again just in case. So what we're going to do is we're going to put this into render doc again. So we're just going to try and see something. Like I just need to see like what it's trying to do. Why can't it render anything? Right, okay, so let's go to a log, yes. And copy of the shaders, because I just don't understand why we're not seeing anything. Like all the data makes sense. What should I even do? I don't know what to debug, to be honest. I'm not gonna lie. Right, okay, so no, it's not updating this either. I was hoping it would come up here, maybe, these things that were donated earlier, but no. Right, okay. Right, so let's just copy our shaders. Because I don't think the assets have changed at all. Just our shaders, which will just be faster. Yeah, okay. This is debug. I didn't compile for release. Okay, dokie. I might look up some particle stuff for lunch, I think. That'd be nice to learn. Because I don't actually know how to do the particles themselves yet. I can write some of the physics, but I don't know, like, how to make the cool, you know, effects random. So that's what we might look up later. So does this work? Yep. Okay, so we have a slower camera because the frame rate is insane. It's like 5K or something when nothing's rendered. Alright, so we're going to launch. Relaunch. So we're going to move backwards. Scroll up just a bit. Right, so what on earth is going on here? So 6 of 6. So texture viewer. Clearly nothing is rendered. We have the texture in here. So it is loaded in memory. Just slot 0. Excellent coloring in there. Next level. And oh, you know what I've done? Oh my goodness, I'm so stupid. I haven't got my toggle track open. I just drove, yeah, went straight into this. Yeah. I was just seeing if that worked. So yes, I've completely not timed myself at all today, which is kind of dumb. Oh well. Alright, okay, so clearly nothing's rendering. I don't know what's it. All the data seems fine. I just don't quite get it. And we got a texture with basically no transparent parts at all. The view projection matrix is, yeah, can be moved back quite significantly. Quite aggressively, actually. This value is very small, so it's not actually like an invalid value. Yeah, I think I've turned them on. I think I needed to click yes on this. I actually don't know, because this was muted before. But I have no idea of checking. Again, please don't feel like you have to donate. But yeah. I did have that muted, I think. Subscriptions do work. Anyway, let's get back on topic though. So let's just see these indirect draw calls. So yes, that is definitely correct. Maybe I should try and debug the shaders. Maybe. Yeah, I'm not giving YouTube money. Set up a coffee. Yeah, no problem. Yeah, I'll think about all that kind of stuff we discussed earlier. Maybe write some notes. I'll see. Maybe what I'll do is like. Nope. That's so annoying. I thought that no. Yeah, thanks for that, Gemma. Actually, that was really nice of you. And I don't see it doing it, sadly. No, never mind. Thanks for just watching. Yeah, okay, I think I'm just clicking on stuff. There we go. You can do whatever you like. Don't focus on it now. Yeah. Yeah. Thanks, guys. Honestly, it's very much appreciated. But no luck, no cigar. It is what it is. Yeah, thanks for all the reactions as well. That's very nice. It's very nice of you guys to try and help out like that. So honestly, very much appreciated. So anyway, let's just debug this a bit, right? So we have our textures, we have our pipeline. We are on the skybox, which has its own unique buffer, which is different. And here, it doesn't have anything here, so we open this up. Particle sets. Yeah, view projection. And yes, we have some regular values here, which makes sense. We did fill these successfully up in the compute shader. What I'm going to try and do actually is there's a way to edit shaders on the fly. I'm just going to have to remember how to do that though. So let's get out of this. Let's get yes, that is the texture itself, but I want to see the output. And we get nothing, so let's close a bunch of this. We got too many of these open at the moment. No, we don't want that. That's just kind of in the way. Launch application, resource, yes. Okay, so how do I do the shader editing again? I got shown on screen probably a month ago. Many game developers are community funded. That's true. Well, I actually don't know if that's true. But that would be cool if it was me too. I don't know. Anyway, I when it comes to all this kind of stuff, I just want to, you know, be a working class guy. But that's like a big dream, you know what I mean? When it comes to this kind of stuff, even that, you know, it's not like I've never been the type to be fantasize about having loads of money. Like sometimes, like I've never played the lottery, for example, because I just don't care about having a load of money. You know what I would do if I had a load of money? I would do this. Literally, this is what I would do. I would just be like, yep, okay, thanks. And you know, if I won the lottery, obviously, you know, if it was just given it by some external force, like this is what I want to do. Oh, this is kind of what I want to do, maybe. Right, I'm gonna just Google this and just see how do you live edit shaders. Why is it saying 2? It's like almost like trying to tell me that something happened. Yeah, 2 notifications. But you didn't pop up on the screen. No, I have no idea. Okay. What am I trying to do? Yeah, not pirate software. Yeah, yeah. Exactly. Like, I love coding too much to not do it. Right. Live editing. Shaders. So this will help me like kind of debug stuff a little faster. Oh, render doc. I've got to remember how to do that. Yeah. Pirate fuckware, I guess. Yes. Yeah. I'll say the little. There is a thing. How do I do this in render doc? I was a fan. I'll say this. I was a fan of him at one point. No longer a fan. And I'll leave it at that. How do you edit the custom? Yes. So no, there's a thing. How do you edit scene editor? Render doc allows you to edit a shader in the capture. I missed something. Edit a custom shader. Allows you to define a transform for a texture view. Okay. To edit a shader inside render doc, simply click the edit button. Edit the edit button. There's a lot of buttons here. Oh, this. No. Okay, so there's. Do I have to? I might not see all the pipelines actually. So we've got texture view, we've got statistics, render, pipeline stage, event, errors and warnings, performance counter viewer, annotation and commands. Where is... right, what are we trying to do? There's an edit button here, but obviously that just kind of does that. I assume that just means we're editing things. But there should be like a shader or something that we can mess with, right? Is there a... Okay, this is a... No, if I mess around with this... And that's just the... So I'm going to go to the... Okay, that's the input image. Where do you do this? I remember we could do this in the fragment shader, maybe. Yeah, no resources, that's true. We don't do anything with that. Right, okay, so this is the depth, and read what Richard Branson did. He's clever and shameless. Oh, okay, never heard of that guy. Peace out from me. I'll be back in an hour or so. Enjoy. Yes, thank you, Gemma. I shall see you soon. Yeah, I don't even know if this is going to be remotely useful, to be honest. I mean, I can see this, but I doubt I'll see anything at all. Yeah, I don't know. And if I git stash, right, I'm going to close this for a minute. And if I git stash, everything works again. Right, I'm just going to have to bite the bullet. We're just going to have to slowly go through this again. Which is unfortunate. Very unfortunate, to be honest. Alright, so let's just start from scratch. So what I'm going to do, actually, I'm going to make exactly the same clone as... Yeah, okay, I know how to tackle this now. I've got an idea. I'm also confused at what the hell the player... why the hell the player doesn't move. When I apply force. Oh, in your game? Yeah, make sure your forces are added up, I guess. I don't know. Alright, it's going to change the music. We've heard this before. Oops. I need to get rid of some of these. I got like so many Ratchet and Clank Trans soundtracks that we're kind of getting a lot of repeats. Let's go with... nothing in particular that I really want to listen to today. I'll go with Challenger. Alright, so let's just bite the bullet. Let's just do it. So, the difference this time, though, is I am going to add a particle renderer, but the particle renderer is going to be exactly the same as 2D in every single way. And then we can beat that up, right? That was the mistake last time. So... I'm going to say new, because I don't want to break the old one, which is going to be lying around. So we're literally going to we're going to go into our source file, right? And... where is that? We have source... it is in graphics. We should have this. So we're going to make 2 of these. The thing we're going to do at the moment is... So, new... sorry, particle render... Particle... renderer... New... Right, so... It's going to be the same thing. And this is how we're going to beat this. We're going to beat it one step at a time. We're going to slowly change it into the new one and see where it breaks. And then we'll have a new... Then we'll know what to do. Oh, we also need a new particles shader, I guess. Yeah, we need that. We need that as well. So we need this twice. Oops, did it again. Right, so this is how we're going to beat this. We're going to beat this today. New, right? Okay, so we just need to regenerate our CMake for that to come into effect. again. Right. And the first thing that we're going to do is fix kind of like the general stuff that wouldn't make this compile. We're going to include it in game. So we need the graphics open as well. So what we need to do here is obviously change this, because this is going to cause all sorts of issues if we don't. So particle, oops, renderer HDR, right? So that's going to stop the naming collisions. We also need to change the basically everything in here to particle type, I guess, or I'm going to say particle. We don't want anything to be the same, otherwise we'll get like naming collisions. So what the goal here is, what we want to do is basically do exactly the same. This is the 2D renderer, right? It's going to have exactly the same setup. But all we're going to do is change the names, so it's not the same. It's not the same as this, because we'll have naming collisions if we did. And then we're just going to try and render exactly the same way, and then slowly move across into what we did, and then hopefully we'll figure out what went wrong along that way. But we need at the very least we need a baseline, right? So obviously we can't have this. So we're going to have a particle renderer instead. So this is only going to be different by name, not by anything else. So this is particle renderer new instead, and everything else is going to be the same. Obviously this is going to be different now. So particle renderer. Okay, next is yeah, this doesn't exist now. This is called something else. This is called particle type, and we need the scene to change as well. So that should fix that issue. And scene 2D is now scene this thing. Okay, so that needs to be changed multiple times, which I don't know how many there are, so I'm just going to kind of do it manually. Yep. Alright. So, this is done, right? So, we have a new particle renderer. It's basically the same code. I'm not going to change anything else. This vertex shader is identical to this vertex shader. The diffing would be no different at all. And now what we're going to do is, instead of having the 2D renderer here, we're actually just going to comment this out so we can do exactly the same thing, because the what is it called? Particle renderer new. It's the compilation errors will tell us where everything is, you know, so particle renderer. Particle renderer. Right. So this is how it's going to work. So we go into here, and we should hopefully get a load of compilation errors, which is going to tell us what to change. Okay, so I'm going to get rid of this completely. Oh, no, I'm going to get rid of that. And that, maybe? Now, when I int it... Yeah, okay, so we need to be careful here. This user interface is not going to be used. So I'm just going to comment this out. Just so I don't have to deal with it. Right, okay, so I don't want to have to deal with it. So we're going to have a particle renderer, add quad, particle renderer, load these things. Right, okay, so null pointer, because we're not going to have a user interface right now. So we throw this in here, particle renderer, and we should have everything kind of the same, right? Nothing should have changed. Nothing should have broken. Everything should be the same as it is after a git stash, which means it should be the same. That took you long enough. There we go. Angelica is a cutie. He's too advanced for his humor's too advanced for us. It honestly trips me up sometimes. But you know, I'm like sometimes half reading the chat and end up kind of, you know, half reading something wrong and then being like, what? I think you need a better code editor. I'm nervous to ask Rock what you use. I feel like this is either I use like Vim or Emacs situation. I don't see those big items. Oh, you don't even see them, flippin' heck. I see. Yeah, I don't even know how you get them. I mean, I can react to my own stream, which seems a bit funny while this is compiling. The reason I'm nervous to ask Rock because because Rock has the, I think I use 10x code editor. Interesting. What is that? That's while we're compiling, we can look that up. 10x code editor. Oh, thank you for the lovely chili there. For 6 joules, thank you. Ah, okay. Wow, I didn't expect that answer. Okay, this is something new. Visual Studio project. Ooh, interesting. So it's like a new Visual Studios. Ooh. So it knows how to parse a Visual Studio project. Interesting, interesting. Okay, this is something I might try. Like for real on Windows at least. I use NeoVim. Yeah, there we go. Okay, okay. This seems cool. Enjoy C++ building again. Yeah, I mean, VS Code has been particularly annoying, I will admit. So, okay, so here we're finally getting to the errors that we care about. So particle. This is the first thing we're going to get rid of once we can. And obviously now we need to change that in the here. All right, yeah, get rid of this particle. Oops, now we got the particle version. So we actually do the billboard rendering properly. Right. This is new. This is, yeah, I've never heard of this before. 10x is a new C++ editor by Stuart Lynch. Developed over 6 years. Almost everything's written from scratch. 10x is a new breed of editor combining raw speed and traditional old school editors. Ah, with the productivity features of modern IDEs. Very nice. Yeah, because they have got really slow recently. Well, recently over the years. Okay, so that exists. Right, fantastic. There we go. Hey, hi Top. Hey, how are you doing? Yeah, I'm good. Doing good, actually. Just wanted to say I watched your video about being an expert and I liked it so much. I'm glad you enjoyed it. I'm glad I provided value. That's like my goal of being on YouTube. I want to be a positive force. So I'm super happy that you liked it. Thank you for watching it, and thank you for letting me know. Yeah. So yeah, it's I'm surprised how well received that video was, to be honest. Yeah, good luck on your programming journeys and becoming absolutely, as the kids say, cracked. You know. All right. So everything works. So what I'm going to do is start removing the flags. The first thing I want to get rid of is this, and this is going to slowly move us in the direction that we care about. So we're going to have this now, and we're never ever going to do an if statement here. Get rid of this flag thing. We're going to get rid of this, and obviously in the vertex shader we're going to change quite a lot. So if we go into the vertex shader, and the first thing that we're going to get rid of is anything UI related, and like this, And hopefully nothing changes and we get everything the same. It's the next step of trying to figure out what went wrong. Oh, yeah, particle billboard doesn't exist. It only has 0 arguments. Yeah, this is fine. Right, do we still see the thing? We don't. We have a buffer out of bounds read. Oh, did we not decrease the size of the buffer on the vertex shader? I don't think we did. I think we still have a flag in here. Yes, so that's going to cause an issue. Hi, dude. Are you building a game? Are you building an engine? Yes. It's going to be like an engine that's specific to me, though. So it's like a game. The engine is going to... It's not going to be like a general tool, like something like Unity or something. It's just going to be like super efficient for what I want to do. So that's the goal here. So we have an out of bounds buffer read. Still the same issue, so let's keep going. And that is for... Not sure what this is for, but that's fine. What do you think of Raylib? It's cool. It makes programming games so much easier. I'm new to it. Yeah, it's a cool piece of cool framework. There's nothing wrong with using frameworks. I think if you're interested in making games from scratch, it's honestly one of the easier ways of doing it. So it's honestly typically very smart to do. So yeah, it's good. I have no complaints. Well, that's nice. Thank you. Yeah, I've been developing game engines for a while now. It's the only way I really know how to make games, to be honest. Raylib is limited, in my opinion. SoCal is worth a look. I see. Okay, yeah. Because I don't use frameworks, I don't really know exactly what the meta is, if that makes sense, right? I don't really know like what's considered. I just know SFLM and Raylib exist. I kind of stick in my lane when it comes to what I'm actually building, which is typically just this stuff. Okay, so we have a out of bounds buffer read. So our buffer is either too small or we're reading too much into it. I can't tell you which one it is. So it's definitely in the vertex shader. So it's this fella. It's not that, because I've made it the right size now. In fact, what we can do is kind of just break this just temporarily and just see, is it the scene data, right? The scene data is used everywhere, so I'm going to unfortunately have to like comment out tons of stuff. But if I just do this, I don't think the scene's used anywhere else, and then we can see which buffer it is, which would be nice to know. Okay, that wasn't what I wanted to do, but that's fine. Yeah, maybe I should use the this 10x10 editor, because the bloody Visual Studios does my head in with all this like squiggly red underlines, which aren't ever errors. Right, so do we still have the same issue? That is the next question. I'm back. Welcome back, Bart. Hopefully you had a good time doing whatever you're doing. So do we have an out of bounds buffer read? We do. So that means it's to do with the quad position, I think. So it's this thing. So if I get rid of these, we shouldn't have any out of bounds buffer read. And what I'm going to do for that, I'm also to confirm this is true. I'm also unfortunately going to have to break the vertex shader real quick, which is fine by me. Wrong vertex shader, fragment shader I meant. So vec 4 1.f 0.f 1.f 1.f, right? So we're going with magenta. And do we have an out of bounds buffer read? We still do. Okay, so it's actually alright, so let's just fix the outbound buffer reads rather than trying to figure out which one it is. There's only a couple. This is interesting though. I didn't quite expect this to be an error that we will come into contact with. So 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 I'm just going to make the buffers bigger. Let's just check the compute shader isn't writing too much data. Okay, so it's writing 1. It's fine. I wish I got past this. It's unfortunate because you guys didn't see the progress I made off stream. And it feels like I've not made any progress on stream now. But I really truly did make something better off stream. And then I broke it as soon as I went on stream. As the way is with life, eh? Right. Okay. So, what buffer is bad? So the size of this. So what I'm gonna do is just lazily just kind of throw in some like numbers here. Like, so that's 10x, which will be way too big and inefficient. Nope, still an issue, still the same, I assume. Is it for... Hang on, is the compute shader... So when I'm actually drawing this, what do I say the max draw call is 1? When I create this, what am I saying the... What is wrong? I just don't get it. It's got to be one of these. So scene buffer then? But that only has one thing in anyway, so that should be the same size. Unless... No, that's the same. Alright, so... We're going to have to go back again, because this is... So, let's go forward in time. Oh, no, let's keep going back, sorry. To here. Yep. Okay, so I'm going to leave the flag in. We're just going to get rid of the argument, though. I'm going to set this... I'm just going to see if I just go back enough. This can't be it, though. Alright, so that's back to where it was. And it always should be billboards, so the argument is going to be whatever that was, which is 1. And let's see, so we go to here and we say flag. You have the flag in it, yep. Oh, it's flags, plural, okay. Ah, wrong. Let's go do here, peak, S, oops. Right, okay, so this is now 1. We're not going to do that anymore. Now it should work again. No, one step at a time. Let's get this one step at a time. So cool. Is it so cool? I'm just going to say so cool. So cool is awesome SDB type header library for graphics. Wow, really? Does it? Oh, that's really cool. I use it on some projects when I don't want to use STL. Okay, okay. So, for those who don't know, the minimal efficient cross, yeah, 2D library, pure C. So, why that's good, why I was impressed by that library, so cool, or so cool, I'm going to say so cool though, is header only libraries are like super nice to use. Okay, so, and the thing's gone. This is so fragile, jeez. Okay. Okay, so let's just go all the way back. Fine, I guess I'll keep going back. I'll keep the names and we'll just remove things even slower. That's fine. And yeah, we'll unfortunately have to add that back in. And remove one thing at a time, literally one thing at a time. rather than one concept. Wow, it's really cool. Header-only libraries are really hard. Well, like I said, STB-like stuff is like always good. Well, you can probably get a bad stuff. I'm not going to say it's like always good, you know, universally, but generally speaking, it's like, I've always had header-only libraries. Have always been good for me. I'm not going to use it personally, but please just be there. Okay, finally. Okay, so what is this value? Oh, it's 2. Okay, so this is 2. Right, let's remove the flag. That's all I'm going to do. Oh, that makes sense. It's a bit shift. Right, so now this is what we did last time. Let me think. So what I'm going to do in the vertex shader actually is remove any... No, wrong. So we're actually not going to touch... So how we're going to do this is that, right? So, that is the minimum. That's the only thing we're going to change. We're just not going to do that if statement. Does it still work? Yeah, okay, that was pretty obvious. It was going to work. Now, everything else has to work. So I'm going to keep this around. One thing at a time, Let's concentrate. So I'm going to set this to... Sorry, I'm a bit more locked in all of a sudden, but I'm desperate to get this done. I really want to get this like done, kind of locked in a bit, like super. Right, okay, so where's this load buffers thing? So if this is 2, does it still work? Big Mike Acton is watching, yeah. The ghost of Mike Acton. We got to make sure our engine's good. Okay, that's fine. Right, 2 is still good. Now, if I set this to something stupid like 0, that doesn't exist. Does it still work? No. So, for some reason, that value changing does screw everything up. So, I'm going to keep this as 2 for now. Now, if I change this to 1, does it work? Now, if this doesn't work, I think what's happening is we're not compiling the shaders. Yeah, okay, so it still means it still needs it to be 2. This hasn't been changed, I don't think, right? Now, question, sanity check. We've got to do a sanity check. Wait, where the hell did that just go? Alright, so are you compiling? Right, okay, so it is compiling. Next, am I even linking to the right flipping shader? I bet I'm not. Okay, so there we go. That was the first answer. Particle new. Right? Does it still work? One thing at a time. One thing at a time. Yes. Okay, so I can set this to a stupid value now. And I assume... Okay, so we can hopefully get rid of this flag. Right, one thing at a time. Let's delete this. I'm pretty confident now we can get rid of these. So we need to remove as much as we can and still have everything kind of work out. Now if I go to game, get rid of that, we should see the same thing and everything kind of work, right? Yeah, I'm gonna have to download that 10x. I'm super excited by it actually. Okay, cool. Everything's still the same. Fantastic. Great. Let's keep moving in the right direction then. Right. So the next thing I would want to do is remove stuff that I'm not going to use in this particle renderer, which is everything other than this. This is just going to be a simple renaming, but it is important. We wouldn't get rid of this. And we call this add sprite set. Add sprite. Sorry, particle set. So that's that. So I'm just going to rename that real quick. We're going to get obviously a bunch of errors, but I want to find that specific one. This fella. Get rid of this. Load buffers is fine. Draw quads. The only thing we care about is this one. I'm going to call this draw particles. Right. And we're going to go back to here. Change this in here. Right. Okay. And... okay. We're getting repeating music, but I really like the song, so... I'm going to stick with it. Now, nothing should have changed. Add particle set. And let's throw this down here. Render particles. What do I call it? Particle something? Okay, I completely... the renaming's not worked. Oh, draw particles, of course. Alright, let's go. Let's see. Do we still get the same thing? We should. There shouldn't be any difference, but... things have broken in silly ways before, so... yeah, we still got a particle. Fantastic. Next change that we need to make is... so we removed a bunch of stuff. Need to get rid of this flag. So this is the first thing I'm kind of nervous about. So... if I go to... what am I doing? If I go to the shader, the new shader, and we remove this flag, does it break? One step at a time. No. Okay, next change that we're going to make. And that is to move this scene data. It's going to call it scene data again. Scene data 2D. I'm going to be pretty aggressive here because I doubt there's something in Windows H is called scene data particle 2D. Now, why did I do that? Because I want to move this out. And I'm going to put this in... was the shader data. There it is. I want to put this in here. And what we're going to do is we're going to go into our 2D renderer. And we're going to remove the same struct that we've got twice. We're going to get rid of this. We're going to get rid of this. Because this kind of worked without this. I don't have to worry about it. Get rid of this. I should get rid of this. This is for just particles. Go to there, please. Thank you. And we're going to remove this file. Function, sorry. And that V. Next, we want to delete this. Go to this thing. Go into our other shader. Get rid of that. Get rid of this. And now we want to get rid of the particle stuff. And only have this for UI. Or slash 2D. Like true 2D. Windows.h has every single symbol ever. I feel like it does, honestly. I've done a search and replace globally too many times and been punished for it. Honestly, there's so many, like, you think, why on earth has this changed 20 comments and 4 function names? You know, what has this got to do with Windows.h? It's so annoying when that happens. And it's like, I hate it when it does that as well. You've got like half a thing, like half of a, like it's changed file names. I know it's changed like a comment, but it's like it's combined 2 words together, so it's like annoying to replace, like move them back. Oh, it's so pain. It's such a pain in the neck. I feel like they have somehow managed to use every symbol ever. Honestly, you've probably experienced that as well, Ratchet. Yeah. It's why you put namespaces and everything, just in case. It makes sense to do that, yeah. I admittedly like global. Mainly because I'm lazy and I don't want to type : over and over again. and then have to use using if I don't want to do that. And it's kind of ugh. Yeah, you're doing the smart approach there, Ratchet, 100%. I'm being risky and probably not wise. But yeah, okay. So we have right. So scene data now needs to be included where it's needed. So I'm just going to directly include it in the CPP file because I think that's the only place it's actually. Oh no, it's not. It's in the header. It actually needs to be in the header. So scene data has been deleted. It's probably already been included by something else, but you know, it's good practice, I think, to include what you actually need rather than relying on files to include other files. Shader data. We did that in our project when... Oh, it's already here. Ah, there we go. Okay, interesting. While at work, and oh my goodness, it just caused a mess. So I'm pretty... I like to keep them all together as well, so that is something I would want to do. So I assume you have the same idea, but you put it in the wrong place, which I don't like it down here because it's separate. Okay, cool. Now I've got to fix the menu, I think. The menu is going to be confused now because it doesn't have a argument. So I'm just going to do that. The 2D renderer is just going to be the 2D renderer. Not much work to type in. I mean, yeah, obviously I'm being a bit of a redefinition. Yes, go rid of this. I don't want this anymore. Yeah, it's just a preference thing. I kind of like global namespaces. I make silly yeah, I say that I'd rather not code like that, but then, you know, I don't use bloody type defs there. That would make my life easier, so I guess I bring it on myself. Alright, so we've done that. Next is to... I'm going to turn this up and then turn it down again. This is super quiet, this track. Draw particle. We're basically almost back to where we were, except we don't have the particle set kind of set up in the same way. We do it with one buffer instead. So I'm going to do that next. I think I have to do this in one go. I think I might rename things first and then figure out what we want to do. So, yeah, so let's do a float pad. Alright, so if I go into my vertex shader now, we have the new one anyway. Instead, oh yeah, we have padding anyway. This is going to be called particle set. And I'm not going to do particle set reference capital letters. I kind of want to do a different name because it is a member variable. Sorry, it's a variable, not a member variable. PTR. Ah, thank you for the lovely star there. That's always nice. I'll pop it up on the stream. Thank you. Considering the bot is not working. There we go. Very nice. Thank you very much for supporting the stream. It's honestly really nice of you. Yes, I wish you would actually behave, but there we are. Bruh, get off my 150 XP, y'all. Yeah. So what Angelica as a cutie is responding to is if you watch the stream, pretty much you get XP and you're a number one. I'm gonna air quotes this fan, but you know, I think I said this last time. I don't really like the word fan that much. Yes, like this. If you like this, I think if you like the stream, you get more. I don't know if people have already done that. You get more XP. As far as I'm aware, anyway. Top yappers. There you go. Number 3. Yeah. Alright then, let's see. Thanks for the lovely gift. Thank you for the sparkles. I'll share on stream as well. Thank you. Since the bot is being done. Yes, the AC is better than fan, but we live in a flat that I'm renting out. And there's no way that we would spend a load of money on something like a proper in-the-wall AC unit. What we really need is a portable one, but they're quite pricey as well. And I would need to... I'm not going to... I think I will end up doing this at some point, but effectively we don't have good windows for AC units. We have like windows that open outwards rather than like up and down, like slide windows. Like, so they're like almost like a door, if you can imagine it like that. Meaning that to have the out pipe for a AC unit, we would need to have like a cover around the whole window. I'm just going to turn this down now because it's about to change. To stop the hot air coming back in through the out thing. Thank you for the jewels. Thank you. I'll again, I'll put that on the stream. Thank you very much. Thank you for supporting the stream so much. Honestly, just watching. It's honestly really kind of you. There we go. It's honestly really nice. So yeah, you need to start refusing. Yeah, that's yeah. All right, I'll come up with a plan, I guess, and ask you guys what you would want out of me and stuff like that. Because I think for the people who support the stream, I would want to do something a little extra, like explicitly. Let's just say there is like a coffee or a Patreon. I'd want to provide extra, you know. It's just competitive. I like it. You know, so I would want to like make it so that, you know, I would want to give like an extra thank you to you guys that want to do something like that. So I'll come up with I'll try and come up with something that's like cool. I don't know what that would be, considering I got a suggestion. My family demanded that I do this, and they were like, "I'm gonna ask ChatGPT." I was like, "Oh, please don't." And it said ChatGPT was suggesting that I open source my code. I'm like, well, yeah, that's already kind of it's already over. It's already over that one. I mean, it's I don't have a license. I think I have an MIT license on it now. If I don't, that's probably due to a lack, not a commit, but you know. But I'll try and come up with something that's like, you know, cool for you guys. It's like a little bonus if you were to help suggest the stream. But yeah, yeah, some of my family members think AI is like the best thing ever. It's kind of it is what it is. But yeah. Thanks for the chili. Thanks for the chili, dude. Thanks for all these lovely emojis that you're sending. It's honestly really nice. It's honestly, I'm super grateful. It's honestly super shocking, honestly. Yeah, to be honest, licensing kind of sucks. I don't really know much about the licensing apart from if you want to proper open source stuff, it's basically MIT, BS. Oh, what is that one? The B1. I think it's BDF. I can't remember. It's the other operating system that's Linux-like. There's the... Oh, there's a load of others. You know, I think the MIT one's generally good. And I think if someone were to take my engine and just say that's their engine, I think it would be a bad look for them more than anything. That would be not a good look. And I would say, why do you want to... Why do you want to curse yourself by using my engine anyway? Oh, I've used the wrong thing here. Right. So we have two things here, which is kind of interesting. So, yeah. What is this used for, actually? What is this used for? That's what I'm confused about. I think this is where it's gone wrong, actually, thinking about it. Yeah, what is this? Get rid of it. What does it break? Nothing? I got a... Oh, nothing. Yeah, okay. That's good. Right, okay. So... That's good. Let's just keep renaming stuff. So this is just particle set with a lowercase p. Cool. Again, we're slowly moving in the right direction. Everything's starting to work. So you've got a CC by NA SA 4.0 on my project just by default. Yeah, I'm not sure what that is, to be honest, but I'm sure it sounds Creative Commons. I think it stands for, actually, Creative Commons. I think I've just vaguely remembered it. All right, so now we've got to be careful. Oh yeah, I want to change this as well. Yeah, particle set address. So yes, this is finally going in the right direction because I'm going slow. I'm just going to keep renaming things. I don't think this is going to break anything, so... Particle set. On my project, I'm using Apache 2. Ah, I see. You say the most random things confidently. Admittedly, my attention is split because I'm really trying to make sure I don't break this. I don't want to suddenly go, oh, it doesn't work now. So yeah, admittedly, my attention is a bit split. Again, if someone wants to steal my bad code, nah, yours isn't bad, but I get what you're saying. It's kind of a joke. Anyway, right. Okay, everything's changed. Now, here's the challenge, right? I don't want to have two of these. I want to have one. And this is not positional. Again, let's just change this to particle set. Particle set handle. No, go back. Right, so... let's at least do that. Particle set handle. Right, I'm just gonna blast over this. 9. Very good. Whoops. Let's not make that huge. Right, so let's build that again. I code in Haskell, so nobody can maintain it. Nobody can pull request anything. Yeah, that's one way of doing it. Maybe I should rewrite my my whole engine in brainfuck just to, and then open source it. I'll be like, oh yeah, you can take it if you want, but you have to get really good at slashes and dashes and hopefully yeah, it's like a funny copyright method. Right, okay, so next step is to remove this. I don't want it frames in flight, obviously. So everything's still working now. Let's remove this and get rid of this. Tab this in. Get rid of this now and this. So we are slowly moving in the right direction, which is great. Okay, right. Does this break? Now this could break everything, so I'm kind of nervous. Yeah, right in... no, okay, good. Cosmic Ray Programming, yeah. Right in... I don't know that one. Malvorge? Not the original creator of that language can make anything. Madness. Right. Okay, so we have that done. We have made progress. We have the particle set set up. Yes. Next is... This is a very simple change, but I want to... What do I want to do next? I want to take what I do in game and kind of encapsulate it rather than just like leave it out in the like. I want to do this inside intit, the initialization code. I want to do I want to also do I want to do all this inside intit because I don't want to have to set up particle data outside of particle data, if that makes sense. So if I just throw this here, we have load textures, and we have add particle set and then load the buffers, right? We get rid of this because these are the same thing, and we see what that does. Does that break everything? Malborge, right. All branches are due to... Oh, yes. That sounds very close to... Okay, cool. Quantum computing, to be honest. Right, I feel like we should have seen a break by now, but I don't really know why everything's kind of working still. But that's fine. If I were to look at... Like, what do I need to do next? Let's see. Oh, particle set. Yes, we need to have an idea of our particle set. So where's the position coming from, actually? Let's think about this. Sorry, not particle set, particle data. So the position comes from instance particle data. What's particle data? This thing. Particle data is what? This thing. Right. Okay. How has this even worked? That's my next question, because this is a vertex shader. Where's this buffer come from? Oh, we passed it in. Right, okay, so that's fine. Yeah, particle data is passed in because we've made the shade stuff outside, which is going to change. So we have the buffer device address. We have the particle data. Okay, cool. Now, can we do more than that? So, instead of having instant rendered stuff for the particle set stuff, oh, yeah, also, I think I've changed too many things to particle. So, yeah, okay, so I want to change this to particle set locase. Just because I like my coding style the way it was. Search and replace is a bit aggressive. And that should do nothing. We haven't changed anything. So what I'm going to do now is, if I keep going. Right, okay, so that's there. And now we want to make sure this is not done by instant rendering, but by the set that is passed in the particle set. Because that's the whole point of this, right? The first step I'm going to do is change these to 0. Apart from the things that are actually instant rendered. So that's the particle set that we're working with. And we should see nothing change, because that's the idea, right? Yeah, okay. Next is, instead of those zeros, is to pull in the particle set itself, and then use that, and just see if that breaks everything. Because something's broken here, and I don't know what it is, but we're slowly moving into the particle set. Now, I don't know if you can do this assignment here, where you can read particle set. So for this instance, we want to do this particle set, this particle set. These stay the same. This and this. We'll see if this is allowed. What have we got? Nope, still the same thing. Okay. Okay. Now, if I'm kind of interested now. If I make another particle set, I've just got to debug something real quick. I think I have a red particle that I can mess with, and I'm going to see if I can change between the two. So that's the next thing I'm going to try. So everything's working. We're going to add more particles today, it looks like, finally. So I'm going to comment this out just so I don't lose it. Actually, no. I can have 2 particle sets. But this needs to be 1. I believe that's going to be the next thing across. Because I think if I look at the image... okay, it's not going to show us. Which is fine, I guess. I'll just look myself. And yeah, so the next one is red. So in theory, that should be the next one across if it's the same size. Meaning that if I change in the compute shader the particle set, which is here, to 1, we should see a red dot, not a blue dot. Right, I think, right? So this is how it should work. Yeah, okay, cool. So we're in a different particle set now. I'm gonna go back to 0 for now. Right. I don't really understand how this is all working, whereas the thing I had before broke. Don't really know what the difference is, but I guess I can do a diff to see. Anyways, what do I want to do after this? I want to check that instance rendering works. So when I create this buffer for particle sets, that needs to be 1. But the particles themselves need to be large enough. So that is in game still. Oh my goodness, that is intense. That is intense. Okay, so that's Malborge. How do you actually say it? It's like bulge, Malbolge. Right, okay, so let's just check this out. So in the buffer, I just want to make sure it's big enough to do this. We're just going to make sure we have more particles to play with. Yeah, so the particle buffer is too small at the moment. Okay, 64. Okay, so it's a... How do we know how many particles we want? Right, I'm just going to not worry about this for now. I'm just going to make it too big again. Because I want to make sure that when we make these particles... Obviously, we wouldn't do this like this in real life, but I'm kind of... I just want to make sure this works without any shenanigans for now. We've got one instantiation of this compute shader, so this is safe to do. So we're going to write to this buffer like this. Again, not what you want to be doing for a compute shader. You want to be doing it for each instance, I guess, and we can't have them all. So let's see if we have 6, 4, and 2, and let's change the last 2 to red. So 1 and 1, right? So we have 2 particle sets and 2 different positions for those particle sets. So we'll see what we do with that. Okay, so we only have 1. Oh, we didn't increase the instance count. This needs to be 1, 2, 3, 4. Okay, so it's 4. Just simply 4. When we create this thing. Yay. So now we should see... There we go. 4 particles. Very nice, very nice. If you can... You can say it like bump or your pants. You can say it like the bump. Right. Okay, got you. Got you. Got you. Right. Right. We're kind of back to where we were, I think. Now I just need to make sure that global instantiation. So how many times we instantiate the shader is not how many particles we want. No, it is, I think. Because we got to transform them all individually. As far as I'm aware, that's how it works. So this is correct, but the draw call thing, we don't want to make a new draw call every single time. And this is what we had last time. So let's... yeah, that was me trying to concentrate on what you said, so I didn't end up going, like... because I'm kind of locked in at the moment. Because I really want to make some good progress today. I feel like I've been stuck on like rendering like 3 particles for like, or like 1 particle for like 2 streams in a row. We want to at least get something kind of cool happening. Right. So oh, let me just check something real quick actually before we continue. It's not going to take too long. Just on my other laptop. Okay. Okay. Yeah, everything's chill. Right. 20. What do we want to do? I want to have 2 draw calls, but I also want to... I want to instantiate this twice, but not have 2 draw calls. I want to have an instance count of 2. And that means that we need to make sure that the last instantiation is equal to the total instantiations, which we looked at last time, right? That was not that difficult to work out. But I'm going to have to go into my GLSL shader and just... total instantiations is different. We did do a bunch of like instantiations. GLS. Where's the? I want the documentation that we looked at last time. This, yeah, this is the one. So we have number of work groups, which is not the total instantiations. Invocations, sorry, I'm saying instantiations, invocations. So this X needs to match the total number of invocations times by the work groups. As far as I'm aware, that's how it works. Or it doesn't work that way at all. And each... So let's just say I have... Yeah, I have a million invocations of this, and I need to run something 20 times for each invocation. So I do have a lot of control over this because I can get the invocation as the workgroup size. I can get the total number of invocations, I think. This is the current workgroup. Which one is it? It's the... That's within a work group. That's not what I want. No. What was it? It wasn't one of these. Was it this one? No. Invocation. Number of invocations. Compute shader. Number of invocations. How do you get the number of invocations? Yeah, it was here somewhere. The exact number of invocations you specify, that is the number of work groups you dispatch. That is the number of work groups you dispatch times by the number of invocations per work group. Yeah, that's what we need. So that is the total number of things, which is equal to number of work groups you dispatch, which is 64, times by the number of invocations per group. So number of invocations per group, I think, is so this is the number of work groups, which I think is the first variable. Oops. Number of work groups dot x number of invocations per work group. So if we have, yeah, what is it? Sorry, let me look at that again. Number of invocations. It's one of these guys. By default, the work group size is 1D at 2D. Okay. Number of invocations per group. Invocations per group. Oh yeah, this is work group size times by work group ID plus this is the ID. I think work group size, I think that was it, right? I think that's, we looked this up last time. And if I can kind of play around with this value, can't I? I assume this is a float. So let's just do an experiment, right? I'm not going to do anything different. I'm just going to check what this value is based on the position of the what is it called? Particle. We're only going to render one particle, and that's going to hopefully tell us what it actually is. And I'm going to do this in the Y direction because that's going to be easy to figure out, I think. So, what is this value? I'm just going to val just to no collisions happen. Right. Hello, mate. Your Britain been going on this fine afternoon? Yeah, I've been doing good. Thank you, Spider-Man Lift, for joining us. It's funny. You know, I was struggling to read that just for a minute, and it reminds me of the fact that when people try to speak like Scottish online, I have literally no idea what they're saying. Like absolute gibberish. But you're supposed to be able to like, oh yeah, this is like how Scottish people speak. It just reminded me of that. Like how I can never understand when people like, oh, I've got to type it out like a Scottish person would have spoken it. I'm like, what are you saying? Anyway, so this is, as far as I'm aware, 1. Whoa, I pressed F by accident. F's in chat for F, I guess. Or is that 0 actually? Let's see. So if I just do a 0.f, I think that's the same position actually, 0.f. So I think we've got a 0 here. No, okay, that was 1. Okay, that's actually really good. So that was actually 1. And if I increase this to 2, what do we get? What do we get? So we get to 2. What am I doing? I'm trying to change the total number of draw calls. So we do need to be in here, and it's the compute shader invocation. So when I increase the compute shader invocation, we should have 2. So I want to make a draw call at the end. So when where is it? So we're just going to make the same thing twice, which is fine. Yeah, we're not going to do this because this is super complicated. I'm just going to say 2 for now. And hopefully it tells us the position is... I'm an LLM, a large language muppet. That's funny. All right. Yep, that's at 2. Okay, this is actually really, really useful. Now, here's the trick. Here's the trick that I'm trying to do. So let's see if I can pull this off. So this is really looking good. So this is, I think, the value that we care about. If we basically worked this out on, I think, Friday. I can't remember when we last streamed. I think it was actually yesterday. I can't remember when we actually did this, though. This is different. But we did a lot of work on this. Is equal to this. And then we want to make a what is it called? Actually, we should use this, I guess. Then we want to make a draw call. But we want to use this as an instance count, right? Yep. So yeah, it would have been Sunday. Yeah. So that was the. And I am going to set this to we're going to set this to kind of data index, I guess. That's just going to change the position quite nicely. We're going to have hopefully 1 draw call and 2 different positions based on this of 2 invocations. So we shall see. Okay, so we don't have anything, I don't think. So right, so that was never actually set. I want to say the... Interesting, okay. So I think we just didn't generate a draw call then. Right, okay. So let's just see what this global invocation does differently. Oh, hang on. I don't think we need global invocation. We need... Okay, so this value uniquely identifies the particular invocation of the compute shader among all invocations of the compute dispatch call. It is shorthand for this maths. No, that is what we want. That is like the counter. Is it too small? Is it too small? I think it might be. I don't know if that works. It might be like 1 off because it's 0 counted or something. Okay, so yeah, we have a particle here. And okay, it's inside the dock, annoyingly. So yeah, we would need to, if we're going to do that, yeah, because it's 0 counted, right? So I think that would work. Right, okay, cool. Yeah. Okay, so that's a little better. We have 2 invocations, so we should see... this needs to also be +2. Yeah, +1 as well, sorry. We might make a new variable name. Yep, okay, so we've got instance rendering, and I think now we have an instance rendering with 1 draw call, which is different, right? So let's just see. I've got to open this on RenderDoc to see, though, because there's no way of knowing if what I've done is correct. Well, I'm going to make this a new variable. Hang on. So global invocation is fine, and instance count, I think. It's just going to make it easier to kind of keep track of. And then we're just going to kind of have it like this, instance count. Because the instance count is a little different. Right, so that should be the same. Yeah, we can get rid of that as well. In fact, cancel build, get rid of this. So yeah, this should be 1 draw call, and this is for the last. So now we can build up another condition, right? If instance count exceeds a particular level, so we can do an instant draw for 10,000. And then we can be like, all right, only, I don't know, for every 10,000 do a draw call. For every, unless if, but also if this is true, then, you know, because we might have a few left over. I don't know what are you compiling? C++. I've literally just edited a compute shader. Whatever. Try and beat up this a bit more. Who knows? While that's compiling. Oh. Yeah. Is there a way to turn this on? Oh, that's just what it's telling me. Oh, look, they're all here, but why aren't they displaying on the screen? Okay, so they can be displayed here, but they're not being displayed anywhere else. Live action? No? Can I make them visible? Mute. What does this do? No. Refresh? I don't know why this is faded. This is strange. So there is something happening here, right? Right. Right, I think I'll leave. What are you doing, Visual Studios? Right, I think it's just kind of broken. Oh, I'm in release. That's what's going on. Right, let's go back to debug. Oh, I'm a doofus. Of course, of course, of course, of course. This is why it's taking so long. I didn't, and I also haven't removed all the validation errors. So, right. So, sorry about that. I was being a bit daft. Right. I admit I was being a bit dumb. Dumbo. So I was compiling for release, thinking that I was compiling for debug, and I recognize now that no, that's not what I was trying to do. Alright, so yeah, release is doing a big compilation. Yeah, I think what I'm going to do is I'm gonna have to watch a tutorial on this and then figure out how to do it properly. So yeah, I'll do that later on though. We won't go down that road again. I think I'm just missing some like stupid thing. All right, so let's put this in. Laptop is dying. So I think today might be the day where we get like at least 10,000 particles rendering at the same time. Yep. Okay. So we just wanted to make sure that was good, and we're getting close anyway. I'm just going to make sure now that we open this up on RenderDoc. Right, so just gonna type in my password 123. Right, now we got RenderDoc. Now we need to obviously copy over the shaders because we've modified them quite significantly. So this is where I thought we would be starting the stream at, but hey, we're here now at least. No, we don't. We want to build. Sorry, copied the wrong thing. Just that. Just so it's speedier. Oh, okay. So we got no resources for some reason. I must have deleted them. All right, cool. Are you gonna work? We have 2 things. Very nice. Next, we're gonna load this into render doc. Launch. Starts. Capture, obviously. Just make sure this is working exactly how I want. So we should have, yep, we have a 1 draw call and 2 instances. Very nice. Next, let's see. Are you ready, gang? We're gonna do something cool in a minute, if I can get it right. So, I don't exactly know how I'm gonna do this, but without any physics, I've got to think about how to do this. We've also got to make this way bigger. If we're going to render, let's try and render 10,000. Let's go for it. We're going to have to make a buffer like huge now, but that makes sense because particles are very small, but there's lots of them. And so that means our first task is going into our game and changing the size to okay, so I've got to change this first. The size of do I have access to this in the new particle renderer? Or is it just internal? So where's particle, not particle set, particle data? Yeah, give me a minute. I'm confused a little bit. Give me a minute. I will, so we need this. Where's particle data? Have I put that somewhere else? Because that's the thing that's actually holding the data. Where is that? So it's in game, yes, here. And it comes in. Mm-hmm. Oh no, it's the push constants. I'm looking for the struct that defines it. Okay, so it's here. It's in 2D. No, that's the vertex shader. Where on earth is the yeah, that's fine there. Oh, it would be struct particle data. Yeah, okay. This is weird. When we create this buffer, what are we creating it with? Oh, interesting. Because we're filling it up on the GPU, it's actually all GPU based. So we don't actually have a struct to even do this with. So that's actually quite handy. That makes a lot of sense though. So if I were to, let's just say, we have 2 particles, so we need 2 different positions. So if I throw in a quick and dirty struct, we're going to have to do a bit refactoring as well, but particle data. And all I do is throw in vec3 s position and uint32 particle set. And this is just to make sure that we've got the size so we can increase the amount of particles that we're going to render. So that's that times by, now we have 2 at the moment, so I want to see if that's correct, right? So I'm just going to kind of make the buffer way smaller just so I can see if that, you know, if it changes to 10,000 and I haven't checked this works with 2, you know, that would be kind of dumb. So yeah. Oh, this is not going to work. Let's close this. So it should be the same old, same old. Yes, fantastic. Okay, so here we go. Here we're going to beat it up now. So 10,000 particles. Make sure it's actually 10,000. So this is going to be a massive buffer in comparison to what it was. Next is to increase the invocations to 10k. Now this may not work for a lot of different reasons, but now we've got to also make sure that we place them all in a place that makes sense. Where is the compute shader at? It's further down actually. So we want 10,000 particles, so we need to make 10,000 fellas. And we're going to instant render all these, so instant render all them. Next is in the compute shader. Now we've got to figure out a little bit of maths. So I'm going to use the invocation ID data index kind of thing. Kind of like figure this out. No, wrong compute shader, please. I assume that this is going to be huge. And I would want, yeah, 10,000 is, I think, is reasonable for a one instance draw call. But now we need to obviously place them in different places based on this. So this is not going to work, because this would work, but it's going to like disappear off. What I would want to do is, if, I don't know. I don't want to do this. I want like a grid, like a grid of them. So, you know what? Let's just throw this in and just see what happens. This might blow up. In fact, it probably will definitely blow up. Oh, okay, so we got 2. Oh, there we go. Yeah, that's 10,000 particles. There we go. That's what we've been trying to do this whole time. 10,000 particles. Now we could obviously go to 1,000,000, but I need some I need a better way of drawing them than just this at the moment. And they're not sorted, so what that means is if we look at them from one direction, it looks fine. If we look at them from the other direction, now you get this like weird effect, right? So, but yeah, you can see this is just going to go on and on and on and on and on and on. And I believe, as far as I can tell, despite using more GPU memory and stuff, I don't know how far this is actually going to go. I feel like I'm never going to reach the end, to be honest. Yeah, so there we go. I need like a better way of like throwing tons on the screen, so I'm gonna spend a bit of time, I think maybe over lunch, like maybe looking up a particle video that kind of does some like nicer simulations so we can actually see them on the screen. Right, 10,000 particles isn't like that impressive, but hopefully by the end of the stream we could probably get to 1,000,000. But obviously I need a better way to display them, and hopefully we don't tank the frame rate. I have a feeling that we haven't done that, so I'm kind of hopeful. Did you make? Sorry, I'm gonna say, are you making your own game engine? Yes. I am just terminal. So we have just rendered 10,000 particles. We're going to try and get to 1,000,000 particles by the end of the day, hopefully. But I'm going to have to go for lunch, which means we're going to watch a video for a minute, right? So I'm just going to look up a particle physics thing so we can actually see how to do how to do a particle simulation without ordering. We're not going to worry about ordering yet. So yes, that's the next step. Right, so particle simulate. Let me think about how to type this into the internet without. Well, indeed. Particle. Okay, maybe we turned our nose up at this guy earlier. Well, I did at least. Maybe never dev. Because he used compute shaders. We're not going to use his, oh dear. Parrot software's come up. This guy. Right, he has a video on particles, but he uses geometry shaders, but maybe he has like a way to simulate them, which might be like a dirty way to like make a sphere. Oh yeah, I love the spiffing Brit. God, I love him. You know what? It's funny as well. He talks about how much he loves Yorkshire tea. Never Deb, yeah, Pirates F. Yeah. So yeah, we need some like particle simulation kind of ideas and like things to do. So I think we're gonna watch this, ignore his geometry stuff, and just see, you know, how do we like get a half decent particle system, right? All right, and then we're probably gonna watch something else. I don't exactly know what, but yeah, maybe this. I don't know. There's a lot of ways of maybe the Ace Roller video. No. Now he uses a function that I don't want to use. All right, we're going to chance it on this, and then we're going to move to Ace Roller's video and kind of skip around it. No, I'm just like kind of hoping that Microsoft's Windows just, I don't know. I've procrastinated like crazy on Windows 10, like sorting it out. Anyway, so yeah, I'm gonna run this through, and then we're probably gonna watch some other particle stuff. We're gonna be all particles today, so particle. Yeah, I'm just gonna get some food. Now, for those who are new to the stream, like just terminal maybe, because I don't want you guys to hear me chew, because I think that sounds gross to me personally. I go and push to talk while I'm eating, meaning that we watch a video together, and then, you know, I still will respond to chat, obviously, if you guys want to say something. But for the most part, I'll be eating just so I can get through this. So yeah. Yeah, it's gross for real. I hate listening to people chew. So yeah, so you don't get tortured by that. I will mute myself while I chew, and you can enjoy the video free of that noise. JS gets Linux and make your engine untestable on Windows because nobody uses it anymore. Oh, is that the just get Linux? Yeah, I see. I thought you said JavaScript JS. Yeah, we could do that. Yeah, I'm honestly quite tempted to do more Linux streams just for the sake of it, so I can get better at Linux development. But anyway, right, we'll watch this, and then we'll go on to a bit of this. We've already watched this before, but I'm probably going to skip around and see what we can do. Hopefully, that's not going to be too agitating for people. But yeah, that's what I'm trying to do right now. Anyway, right, I'll be right back with the with my food, and then I'll start the vid. Oh, I also need to turn up the audio here to about 70-ish. That's about right. Let me just play a bit of the video.
Particles.
Make sure the audio is good.
Smoke to snowstorms
So that's a
and
bit
fluid
quiet.
simulation. They've
Let's turn him
captivated
up on the
us since the
YouTube.
beginning of time, and even to this day,
How's
people
that?
gather in
Oops,
droves to
that's
watch
not-
particle effects out in the
Okay,
real
it's a bit
world.
loud. Let's
Even in
turn it
games,
down.
they've been right there with us from the start, as early as Space
And,
Invaders in the shape of
that's about
animated
right, yeah.
sprites, all the way up to today with complex
Okay,
particle
cool.
simulations
I'll
across.
actually start the video again. And yeah, I'll be right back. Yeah. I've made a packed lunch, so it should be pretty quick to set up. I obviously want this to be as short as I can. I don't know if you guys can hear me. Just forgot where I put my food. So yeah. Let me just sort something out and I'll be right with you with the video. Alright. Well, hopefully you guys can hear me anyway. Just yelling in the kitchen. Alright, I'm back. I will go to push to talk and we'll watch this video just to get some ideas about how to simulate lots of particles so we can test things. And then we can start worrying about like how to make things look nice later. So yeah, let's give this a watch. Remember, we're not going to use geometry shaders, so we can skip over that and the rest is probably useful. Anyway.
Particles. From fire and smoke to snowstorms and fluid simulation. They've captivated us since the beginning of time, and even to this day, people gather in droves to watch particle effects out in the real world. Even in games, they've been right there with us from the start, as early as Space Invaders in the shape of animated sprites, all the way up to today with complex particle simulations across a plethora of games and game engines. So today, we're going to implement a particle system for Never Engine. So grab your coffee, maybe a little snack, drag me over onto your non-work related monitor, and let's get started. First things first, in order to have many particles, we first need to have one particle. And in order to have one particle, we need to figure out what a particle even is. As with anything, it really comes down to who you ask or what game you look at. But in its simplest form, it's just a position that's rendered as a quad, also known as a billboard in computer graphics. Here you can see that to render a quad, we render two triangles. Triangles simply because GPUs really like them for reasons we won't get into in this video. Actually, screw that, because I've wondered this myself for the longest time, so let's find out together. So as it turns out, one big contributor is that the 3 points making up a triangle will always lie on the plane that that triangle creates, simply because you need a minimum of 3 points to create a plane. This makes it a lot simpler to clip triangles and create new ones based off of what can be seen on screen. However, that is not the case for quads or any other higher dimensional polygon, as you can see here, where one or more points can lie outside of that plane. Now with that out of the way, to start us off with our particle billboard, we're just going to send over the particle positions as individual vertices in what is called a point list to the GPU. The vertex shader in this case just forwards the information over to the next stage, and here's where we plug in a geometry shader, which as the name suggests can either add, remove, or modify the geometry that's being passed in from the vertex shader. In our case, we are using it to create two triangles forming a quad facing the camera. We do this by transforming the particle position into the camera's coordinate space by multiplying it with a camera transform, and then we just stretch the particle out horizontally and vertically to find the corners of the quad. We send over those new vertices to the pixel shader, which for now will just output white, and with that we now have our very own billboarded particle. The neat thing about having one particle working is that it's trivial to add more. So if we just add 99 more particles and randomize their starting positions, it should look something like... Now that's already quite promising. Sure, it's not all that impressive, but if we use our imagination, there's nothing but possibilities from here on out. The next thing that our particles need is a lifetime, which brings up the question of how we want to store our particle data, since right now our particle is nothing more than a position. As it turns out, this is actually quite a good way of storing data that you want to iterate over in succession. That is to store all of the particles' positions together, and now we'll also store the lifetimes in the same way. This is called structure of arrays, as opposed to array of structures, where we'd store all the data relating to a single particle together as one. Like this, where we have the position and the lifetime of one particle together. Then after that, there's another one, and another one, and another one, and another one. The reason why the structure of arrays approach is beneficial in our case is due to the fact that we store runtime data in RAM, random access memory, and it takes a lot of time to fetch data from RAM, especially relatively to how fast we can compute it. Here you can see an example of how much time it takes to access the different caches as well as RAM relatively to each other. In fact, cache misses tend to be the leading cause for CPU bottlenecks in games. Check with your family developer if there's anything you can do to prevent this in your own projects. Knowing this, it's important that we organize our data in such a way that it's as tightly packed together as possible in regards to how we access it, which in the case of our particle lifetimes, we can now run through all lifetimes and clear out all the dead particles in one fell swoop. Since the lifetimes are all one after another, when we ask for one, it'll get multiple every time. So as we're looping through them all, the CPU recognizes that we're fetching memory linearly, so it can do what's called prefetching to try and ensure we have the data available when we need it so that we don't have to wait. So with that in mind, we can now set up our array of lifetimes and put that above the positions. So now when we spawn a particle, we'll add a random lifetime between 2 and 5 seconds and add a simple check as we loop through the particles every frame and remove the ones whose lifetime is smaller than the current time. It's worth noting that when I remove a particle, I do so by copying the last particle into the removed particle slot. That way we save some extra performance by not having to shift all the other particles down. I still feel like there's something missing. With particles dying left and right, we also need to be able to spawn new ones. So we'll add a spawn rate and use that to decide how many particles we should spawn every frame. To start us off, we'll set it to a modest 20 particles per second, flirting with the limits of what our 100 particle rate can handle. Now I don't know about you, but to me virtual particles popping in and out of existence is not really that impressive. So to really wow the big guys upstairs, I think we need to add some forces into the mix. So let's just try applying a poor man's gravity on the particles every frame, maybe add another particle value for size and color, that way we can modify the size of the billboards to make them elongated or stretched. And if we spawn them a little bit further above, utilize the color's alpha channel for transparency, and then if we throw in just a dash of imagination, it kinda looks like rain. PS1 era rain, mind you, but rain nonetheless. Regardless of how nice looking we can get this rain, there's really only so much you can do with 100 particles, so I think the next step is to make our particle count dynamic. Thankfully, I don't think that should be too difficult. Currently, we can figure out the max amount of particles that can exist simultaneously by taking the max lifetime of our particle and multiplying that with our spawn rate. Once we have that, we can simply allocate that many of each type of data that our particle contains. With so many more particles at our disposal, I think it'd be worth to add a variable to keep track of our particle's velocity. That way we can more accurately simulate gravity and give our particles a much better sense of momentum. To support this, we'll have to modify the update function a bit to instead add the gravity force to the velocity, and then in turn add the translation delta from the velocity onto the particle's position. If we now also add a way of setting the starting velocity and generalize the gravity into a velocity delta modifier exposed to the editor, we can create a bunch of different effects, like so. We now have a pretty effective way of updating and rendering our particles, but one big glaring problem we have currently that I've had a really hard time finding any resources on, and it was actually one of the reasons I decided to make this video, is the fact that we currently can only have one particle effect running at any one time. And on top of that, to make things even worse, currently we only have one emitter. That is one rule set for how and from where we spawn our particles. To fix that, I have an idea of how to split up our data as well as our logic, and that is to have particles at the bottom layer, like we have now, but instead of having the particle system owning the particles directly, they'll be owned by something we'll call emitters, which will handle the logic of spawning, in other words, emitting particles as well as updating them. That way we can separate out different spawning behaviors into various emitters, which will then in turn be spawned and updated by the top layer, which we'll call particle effects. These are the actual assets that contain the information on how a particle effect should behave and look like, such as an explosion, fire, or rain, like we just created. With this approach, a particle effect can have multiple emitters of different types. In the case of an explosion, you might have 3 different emitters using different behaviors, such as one for the fire, one for the debris that shoots out, and one for the smoke that rises after. So now that we have an idea for how to divvy up the logic, we just need to figure out how to actually go about implementing it, and making sure that we're doing so with performance in mind. Since it's likely that we'll have multiple emitters of the same type, I think it's a good idea to create big containers of particles for each emitter type, which can then dynamically grow or shrink based on the demand. Setting this new flow up is fairly straightforward. We just move the spawning and updating logic into the emitters, add a new asset type for our particle effects, and have our particle system accept those asset IDs as requests. And inside the particle effect, we'll add some logic to determine when to spawn a new emitter, as well as keeping track of which active emitters it has so that it can update their transforms, since the particle effect itself might be moved and or rotated throughout its lifetime. With that sorted, things should now look exactly the same. And whoop-de-doo, they sure do. As I've been making a few different particle effects, it's quickly become painfully obvious that with the current non-existent tooling, it's just simply not that fun to play around with. So what if I made a sequence editor real quick? Since I'll need one in the future for animations and such anyways, I might as well do it now. Also, wouldn't it be cool if it worked sort of like Photoshop, where you have groups with modifiers that only affect certain layers? And now I just need some cool modifiers that work on the particles within that range. Not gonna lie, It's actually quite fun to make particle effects now. Now there's one particular particle effect I've been wanting to make this whole time, and that is the mother of all particle effects: fireworks. But if we want anyone to buy our fireworks, we'll have to really sell them on it. And to do that, we'll need a few things. The first one being bloom. Nope, not that bloom, this bloom. The second thing we need is functionality to spawn emitters from particles, preferably both through a tick and a death event. So we'll just quickly toss that in there as well. Third thing is not really necessary, but gosh darn it if it isn't cool. The power of scrubbing while being able to follow a particle's path, both forward but also backwards in time. There's a reason why engines such as Unreal doesn't do this, because A, it's not really that important, and B, it can complicate a lot of logic. But like, doesn't this look cool? Like, what the fuck? That's so sick! I'm so unbelievably happy with how it turned out, and this is the moment you've all been waiting for. I present to you the mother of all particles, Eartha. If you want to try out the particle system for yourself or just want to support the development of Never Engine, I've started up a Patreon where you can get access to the latest version of the engine itself with limited to no support beyond getting it up and running on Windows. I just finished up a contract I've been working on for the past 6 months, which is why this video has been delayed quite a bit, but I assure you, I've been working on a lot behind the scenes and there's a bunch of topics that I didn't cover or even touch on in this video, like what I did to optimize the system with multi-threading, SIMD, the hell I had to go through to make particle system work deterministically, and so much more. If there are any particular topics you'd like covered, do share them down in the comments below. I read through all of them and try my best to respond as well. Thanks so much for watching all the way until the end, and if you want to hear more about Never Engine and its progress, subscribe and join the Discord with a...
Okay, I haven't finished eating yet, but CPU based. This is completely different what I do.
Hello everyone! Recently, I watched the 2023 biographical film Tetris from Apple TV, and I had two major thoughts. The first was, wow, this is one of the worst movies I've ever seen in a way that's difficult to put into words. The second was, wow, has anyone talked about Tetris beyond its financial success? It is an actual thing after all, more than just an entry on the best-selling franchises list. So today, we'll be remembering Tetris through a developer's perspective, observing how it's evolved through the years, reverse engineering the games, and analyzing the critical design decisions that have accumulated over the years that have transformed Tetris into such a phenomenal gaming experience. Originally from the 80s, Tetris has a long history that has been covered time and time again, but always with a focus on its emergence from the Soviet Union into the greater Western gaming industry and the war over distribution rights between the Maxwell family, Sega, Nintendo, the creator of Tetris himself, and whoever else was involved. In modern times, Tetris is like the Citizen Kane of video games. People often cite it as the best game ever made, probably because they heard someone else say that, then just started repeating it themselves. But lately, I've been wondering about what actually makes the game so special. There's certainly some aspect of its design that leads to the so-called Tetris effect. What interests me most is the design history of Tetris and how it changed from its first inception to the most recent Tetris release. From my ignorant gamer point of view, Tetris feels like a living fossil of game design. I don't think it's changed much for as long as I can remember, but admittedly, I haven't really played Tetris a whole lot, so I'm looking to verify if my assumptions are correct. Has Tetris meaningfully changed at all over the decades? is? If so, then how? If not, then why? To do this, we must go back to the past, to find the very first version of Tetris, something the Tetris company doesn't want you to find. But first, a word from this video's sponsor. If you have ever tackled the incredibly tiresome task of localizing an app to a number of different languages, you probably don't want to ever do that again. But with the help of today's sponsor, General Translation, shipping with multiple language support has never been easy. Even General thanks so much history of Tetris
like
games, the devices in my room automatically read my brainwaves and informed the advertising companies of my new interests, resulting in the recently released Tetris Forever showing up in my Steam recommended. Tetris Forever came out in 2024 and is developed by Digital Eclipse, an American game studio known for developing compilations of games from retro franchises combined with behind-the-scenes documentary-style information. Tetris Forever is, of course, the Tetris version of this, a celebration of the 40th anniversary of Tetris, chronicling the many grand releases in the Tetris franchise over the years with an amazing documentary on the formation of the Tetris company. Wow, this seems like it was exactly what I was looking for, but before I went through with buying the game, I received some information across the morphogenetic fields, a thought from across time and space. The thought told me to Google Tetris Forever Reddit, leading me to a Reddit post for an article on the game from a real Tetris gamer. Tetris Forever is marketing disguised as a documentary, discusses the many holes in the game's retelling of Tetris history, choosing to focus on the story of the Tetris company rather than the story of the games, the players, and the general Tetris community. I don't really care about any of that though. I care about the influential entries of the franchise so I can study the evolution of Tetris game mechanics, and unfortunately, Tetris Forever left out a lot of important titles. According to the article at least. I'll never know if this is true or not because I ended up not playing Tetris Forever. Do I look like a guy with $35? Instead, we'll have to find the first version of Tetris somewhere else. You probably didn't notice, but we all pulled a trick on you just now. There was a little bit of misinformation slipped into the last section of the video, baked into the game's release, and in the article I cited, a little bit of a marketing ploy to make Tetris Forever seem just a tad more special. A harmless dose of historical revisionism that I've now helped normalize. Tetris Forever was released as a celebration of the 40th anniversary of Tetris, and since it came out in 2024, this would imply Tetris was created in 1984. But is that really true? The 2004 documentary Tetris From Russia with Love cites spring 1985 as the date of Tetris's creation. So what happened between 2004 and 2024 that caused the anniversary year of the franchise to be pushed back? A post titled June 6th, 1984 on the Tetris Concept Forum discusses how prior to 2009, everyone agreed the release date of the game was 1985. The Tetris Zero copyright registration states 1985, and in a 1997 press release, Blue Planet Software, which would later become the Tetris Company, wrote that Tetris was created in 1985. In 2009, Blue Planet Software hired PR firm Grayling Connecting Point to market the game. On June 2nd, they launched a website celebrating the 25th anniversary of Tetris, scheduled for June 6th. So the goal was clearly to get people excited for Tetris by any means possible. In this case, it seems the any means possible meant just making shit up. 2009 minus 25 is 1984. So to support this marketing campaign, history needed to be rewritten. But can you really blame them? Celebrating the 24th anniversary sounds lame. The Tetris Company told you to reject the evidence of your eyes and ears. It was their final, most essential command. It's kind of wild that a company would just lie like that, and 15 years later the lie is continually perpetuated. If you Google Tetris release date, you'll get June 6th, 1984. The AI overview says the same. This national CIO review does the same. They're all feeding into a lie without knowing any better. Is there a greater evil than marketing? Now we know it doesn't go any further back than 1985, which means this version right here on DOS Games Archive is the original Tetris experience. How different do you think it will be from your current mental image of the game? In 1985, Alexei ported the prototype Tetris created on the Electronica 60 to the IBM PC, which is where the real story finally begins, with this version's release in 1986. After pressing any key to continue past the title screen, we're met with a list of game settings. First, we can choose between playing the game or watching a demo. The next setting enables or disables previewing the next incoming game piece. The third setting enables or disables phantom shapes, which are invisible and very annoying to play with. The level is the speed at which the blocks fall, which increases every 10 lines cleared, so there isn't really any reason not to start at level 0. Lastly, we can decide how many lines of trash we want to start the game with, and after pressing space to start, you can see that the game looks like Tetris. Shapes composed of 4 cardinally connected blocks fall from the top of the board to the bottom. The player can nudge the current falling shape left or right, rotate the shape 90 degrees, counterclockwise, or drop the piece to the bottom of the board. Completed lines disappear, with remaining blocks taking their space, and the game ends when a new piece cannot enter play due to overflow. Well, if the entire game can be described in that short of a time, surely it'll be easy to recreate it ourselves. None of this game stuff can happen without a game board to play it on though, so let's start by creating a grid of blocks before concerning ourselves with any game mechanics. While this version of Tetris is very low scope, and a straight line optimization focused approach would be a fun, trivial, weekend project for the university sophomore, our overarching goal is a generalized solution that is malleable enough to experiment with and accept the quality of life changes of future entries in the series. A straight line solution wouldn't be easily modified, and it's not the 80s anymore, so there isn't actually much value to a completely optimized Tetris solution aside from intellectual masturbation. So unfortunately, we're going to be software designers today. The methods I utilize are not in any way indicative of how they may have done it in the past, but don't worry, I have a degree for this somewhere at my parents' house. Given an empty 3D scene, how would we go about making a game board to play Tetris on? Ideally, the board should actually exist in space so it can move around and be resized. The Tetris board is a rectangle, so we can create a cube, invert its faces, resize it into a 1x2 rectangle, and now we have a fancy container for our game objects. Implementing Tetris in a game engine is a bit strange, because it isn't really a game that lends itself well to what a game engine offers you, that being a space for different scripted objects to interact with each other. Instead, the creation of our game world is basically already finished, and our little rectangle is going to handle all of the game logic, displaying the current state of the game on itself. In this sense, our Tetris is like a game within a game. This means the game we're playing is going to take place in an imaginary space, then displayed on a rectangle that is in the game engine space, which makes visualizing the game state a bit more annoying. Thankfully, our imaginary coordinate space isn't too complicated. If we look at Tetris, we know it's just a two-dimensional.
Why do game devs do this? He's what I call, a game engine user. Literally making Tetris without a game engine is easier. Then he proceeds to use a game engine. Bro, just don't use a game engine. Oh, it just makes me laugh. Yeah, intellectual masturbation is what programming is all about. Me and my 35 cents will let you know. Well, we'll tell you that's true. Well, actually, if you do the currency, that would be like 20p in pounds, so it's even less. Anyway.
Grid of blocks at integer coordinates. We could say this spot in the bottom left is the origin, 0, 0. X increases to the right, and Y is up. Our game board could be arbitrarily large, but original Tetris has 10 columns and 20 rows, so we create our imaginary game board by instantiating a list of 10 by 20 tiles. A tile is an object defined by us that knows its position in Tetris space, knows if it is occupied by a block or not, and holds a reference to the block, if any. The 2D position of the tile corresponds to its one-dimensional index in the game board array, so we can easily check if there's a block at any position like 4, 5, or 6, 7, or whatever, and also easily place blocks wherever we want by instantiating a block and then asking the tile at a desired position to hold on to it. When our game is running, if a block is placed at the origin, then we want a block in our game engine world to appear in the bottom left corner of the rectangle board. While that block may be at 0, 0 in the Tetris space, it is not 0, 0 in the world space. Game objects all have their own combinations of translations, rotations, and scales called transformations. Child objects of a given node will inherit the transformation of their parent, such that any subsequent operations are relative to the parent instead of the greater world. The hierarchy of our game objects is going to look like this, with the game engine world at the top, the parent node of our Tetris game object, and the game board itself, which holds the mesh and also the scaling transformation to make it a 1x2 rectangle. The reason this matters is because the cubes we're going to spawn to represent the Tetris Tetris game state will be children of the game board, and so we are not transforming from Tetris space to world space, but from Tetris space to the game board space. This means the origin is the center of our game board mesh, and also that we are inheriting the 1x2 scaling. Now imagine we overlaid our 10x20 Tetris space over the game board. 0, 0 in Tetris space would correspond to this spot right here. So we just need to move from the midpoint to the lower left corner by subtracting by 1/2 of the side lengths. Then to center the cube, we divide the horizontal side length by the number of columns to get the side lengths of the Tetris blocks, divide by 2 to get the midpoint of the columns, and add it to the position. Now we just need to properly scale the cube. Since we inherited the 1x2 scaling, we undo it by scaling by the reciprocal to return to cube form. Then we want to fit snugly with all the other cubes in the row, so we scale by 1 over the number of columns. And now any cube in the Tetris game will find its proper spot in the game board. Obviously, this is just a simplified unrolled matrix multiplication, so we can combine this translation and scale into one matrix, and now we have a general use transformation from Tetris space to the game board space. To fully represent the game state, each frame we wipe the game board, then iterate through our list of tiles and draw all existing blocks. If I add a block into the game board every time I press space, we can see it works great. The original Tetris is 2D, so we want to change the camera from perspective to orthographic to get rid of the depth perception on our game board and blocks. That took more time to explain than I thought it would, but now we can implement Tetris game mechanics, starting with player interaction. In the wonderful world of Tetris, you have a whopping 4 decisions you can make at any given time. Move left, move right, rotate the shape, or drop the shape. Let's start simple by creating a basic shape to prototype our movement with, a single block. Our game master will keep track of all currently active blocks, so when we place our block into the top of the board, we also add it to the list of active blocks so we can apply our input logic to it later. Moving is pretty easy. Given a desired movement direction, the active block will take its position plus the desired movement direction, check that index in the game board, and move to it if it isn't out of bounds or already occupied. This general functionality covers 2 of the 4 Tetris inputs, moving left and right. Let's skip rotation for now because it wouldn't do anything to a shape made up of 1 block. This leaves us with dropping the block, which isn't so hard. We just start at the bottom of the column and iterate upwards until we find the next available spot for the block, move it there, and remove it from the active list. Then we start over again, placing a new 1x1 shape into the top of the board and adding it to the list of active blocks. Since we can move the block and also drop blocks with ease now, we can implement the general Tetris mechanic of moving the blocks down at each step of the game, also known as gravity. We keep a timer going, and when the timer exceeds a given threshold, then we move the block down and reset the timer. If the block can't move down, it is locked in place instead, and we move on. Since we can place blocks now too, every time a block is placed, we want to check every row of the game board to see if all of its tiles are occupied. If they are, then we remove all those blocks from the game board list.
Okay, I think we'll leave it there. Oh, I forgot to put something away. I'll yell at you from a distance while I do this. So, let's pause that. I realised that my maths might not be strong enough at the moment, so we might have to do some mathematics, looking up and kind of a bit of studying. The problem is I'm having right now is imagining how to do, you know, different particle effects. Like off rip, I'm not going to be able to do that. The other thing I would want to do as well is just make sure this works in RenderDoc. Are we actually doing one draw call for 10,000 instances? So obviously we need an age thing as well, which is kind of like how do we deal with age. I think what I'm going to do is basically have a velocity and position and particle set. I think that's how the if I looked at my notes, how when we were looking this up earlier, it was in source notes, so because we didn't finish, so we might end up having to go back to studying for a bit, but I don't think so. I think what we're going to try and do is just beef up the renderer for a bit. We avoid minus. Yeah, it's yes, we have to. I don't know what to say to that. Where is the yeah, book? So this was This? Yeah, so we were taking notes and we said, so yeah, we have basically age and velocity is one thing. Oh, position is a Vec 2? It's a Vec 2? What about the depth? What? Your graph looks like a map of the Earth. Does it? Oh, yeah. I see what you're saying. Yeah. Unfortunately, it's different every time, so where's the... No, I've got rid of it. Yeah, yeah, I can see what you're saying. But it looked better before. Anyway, so... That's really interesting. They did age and velocity... So velocity, they did a one-dimensional velocity and a two-dimensional... Is that correct? I might have to look this up. Because I'm confused. Like, how did they then do particles in 3D if they had two components? This is where this book kind of gets difficult though, because they have like tons and tons and tons of stuff, and it's super optimized. And I wonder if they have an is active in this bit mask. Or bit field even. Yeah, they have like multiple zeros here, which is kind of interesting. Index, okay, so what I think is you work your way through. And then we got to collage stuff with the depth buffer. Yeah, because what I have at the moment is pretty big in comparison to this. Because what I was going to have to do, what I was thinking of doing, right, just without thinking much, was maybe doing something like vec for velocity and age. Kind of like that. That was the only thing I was kind of adding, right? But they look like they've somehow compressed the data down into 2, which obviously is that's so much better. Anyway, so the other thing is I've got to worry about. Go back. Thank you. Is I need to have like a way of doing physics simulations. Oh no, particle simulations. So we need to do a bit of maths. Because this is, you know, interesting, but like, you know, 10,000 particles in one direction is kind of boring. I mean, it's cool, but like, you know, I could just do this with a line. Yeah, so I don't know what to study immediately, or like what to look up. So we need to order things, I think, if we have transparency. If we don't have transparency, this is fine, but I don't know how I feel about things at the moment. So yeah, let me just plan a little bit, because I'm trying to... yeah, so I'm going to plan from my position. So what I think I'm going to do is maybe start adding some physics into this. And maybe there's a way of like maybe randomizing the starting position and kind of like having a basic, you know, particles moving around the scene, you know, at some kind of speed. And we can, excuse me, let me just clear my throat. Yeah, I mean, this is like theoretically cool, but yeah, I would need to have something to simulate. We did this last time where it's just impractical to see like how far this goes. Like, I'm going as fast as I can to get to the end, but because I've rendered 10,000 particles in this direction, it's gonna take 10,000 units of movement. It's kind of cool though. And I know I'm mostly playing around now, but I'm trying to think. What am I lacking? I think. What I need is more of not like. I think. Okay. First things first. I think we've succeeded in getting kind of like the basic idea down. Yeah, there's multiple things I need to learn / do. Let's get rid of this. So we need to add particle logic. We've done the draw call thing. I think I'm just gonna steal. So yeah, that's what I'm gonna try and do as well is figure out what I got wrong. Yeah, and we can use different particles sets, which is quite nice. You know, if I was to do something like, I assume we can do a modulus operation. Something like that. Okay. Can you cast like that? Or yeah. Yeah, there we go. So they're different particle sets. Red is its own particle. It's got its own texture. It's got its own thing going on. So yeah, we can easily move to a different particle set, and it can have its own like size and orientation and stuff like that. But yeah, so that's actually really good. Goal is today is obviously to render 1 million, but we also need to have like a way of excuse me. I don't know what's wrong with me. Sorry. A way of rendering them in a way it's like a little bit interesting, so we don't just have a line that goes off to 1 million. Because like, what does that look like? Who knows? All right, so let me think about this. I don't want a super complicated simulation, but I've also got to worry about age if I have a spawner, if I have an emitter. I don't know what to do immediately. I think if I'm going to do a compute version of what I'm trying to do here, the thing is with other people's implementation of particles is they're going to be using, without a doubt, almost guaranteed that they're going to be using a CPU approach, right? Like we just saw with Neverdev. Neverdev is using a CPU approach, and then he's using a geometry shader to create the geometry, right? Now, I was kind of like excited to see the maths, but then I realized, wait a minute, everything he's doing is on the CPU, and his optimizations are all CPU based. So it's fair. Here's the thing. Maybe that's like appropriate, but for rendering over like, 50,000 particles plus, you're gonna have to start being a bit more intelligent by what you do. Which suggests that if I want to continue down this path, which may take me longer than I want, I'm probably going to have to investigate this book a bit better. At the same time, I think we can add physics without doing this, but so I might do that first. What I'm talking about is the GPU Zen book, right? Which we've been reading on stream. This thing. So if I go to 1, 2, 3, right? Like this is his way. This is their way of doing, like basically billions of particles on hardware that. Yeah, it is uint 2. Oh dear, it's even more tightly packed. Interesting. Anyway, so that's actually wrong. That's even worse. It's a uint. UVec2. So yeah, it's a tricky one. And we got to figure out what to do. Yeah, because I feel like no matter what we look at, like I said, like I know I keep saying this, but we need to be able to kind of deal with this kind of stuff, right? Which is kind of tricky. I see. Okay, so right. I was wondering what was going on here. So there is a packing thing that they're using here. I think that limits the amount of okay, that's actually kind of useful. So it probably limits the data that you can use, but with this idea you can pack more data in so you can render more particles. So this has a lot more complications when it comes to so I'm just scrolling through just so because I don't really know. Like where all this is being done. Oh, so this is definitely in a compute shader. Okay. Okay. Yeah, so I need to be careful here. The reason that I'm not like immediately jumping on this is because of one thing only. And the question is, do I need to do this? Am I going to overkill myself, kind of like over-engineer like a particle system that's like never going to be used like to the way this needs to be used, right? That's what I'm trying to think of right now, because it's important that you know, that we do as little as possible to get the maximum amount of results, not out of laziness, but out of you know, so we can make use. Is this all compute shaders as well? Okay, no. That might be compute shaders there. Okay, so that's fine. Because this uses 3 buffers, and it's kind of, I don't know how to use them. It has a data field buffer, and yeah. So it looks like what we're going to do then today is go through the packing, I think, and see how. Yes, we have a lot of things in here. Is this okay, so we have a lot of like a lot of code in here that we can start writing, and I assume this is all going to go in a shader. Yeah, so I think we'll do this later. We'll try and pack the data in, but for now I think for our own like fun, we shall look into the old kind of way of, because this doesn't talk about how to do the actual physics, so I think it might be worth looking at our old compute shader to see how compute shader maths works, and hopefully we can set the positions of these compute shaders to like something cool, even if we're not packing the values. If we're not packing the values, then we might lose, we might not be able to get to a million particles, but we can probably get close. Yo, thank you for joining us. Wanted to ask, you wanted to ask me the other day, but I forgot. What do you use for time tracking for pair project? I'd like to do that too. Oh yes, toggle track is useful for that. So for example, if I just set off a timer, like without any thing on, what you can do is you can set up a project thing for your, you know, whatever you fancy doing. Like for example, if you're doing a hacking project, then you can type in something like, I don't know, hacking Minecraft or something, like that. Then, you know, throw that in. That's the hacking Minecraft, and that mixes in with other stuff. I'm pretty loose with the projects, to be honest, as long as I'm doing something useful. But yeah, that's that I do, and you can obviously delete, which I'm about to do, and edit the times. So if you've been hacking, oops, I forgot. I've been hacking since 12 a.m. right? Oh, sorry, p.m. You can be like, yeah, I've been hacking for 2 hours, kind of thing, right? So no, I don't like automatic stuff. Because the reason is it's not deliberate. For example, the Visual Studio there's a Visual Studio extension that like counts how long this has been open for. That's not work, in my opinion. Just because you've got a project open like this doesn't mean you're doing anything. Like, I'm not working right now. I'm talking to chat, right? You know, I'm talking to, you know, chilling out, having a good time. Just because I have this here and I'm like highlighting the text and being like, okay, doesn't mean I'm actually working. It's all about deliberate practice, my system. So that's why I like me having to click go on something, you know, because then it's like, all right, I'm starting now, and then I stop when I've stopped, right? So yeah. So so hopefully that explains what my methodology is. Yeah, because my pet peeve, well, not it's not really a pet peeve, to be honest, but it gets a little annoying when people say that they code for 16 hours a day, and you find out like what that means is, oh, I had my editor open for 16 hours a day and it said 16 hours. That's not the same. It's you know, you can be playing a video game and still have the editor open, you know. That's why with my system, I made it public for people to use. In that video about how to become an expert, but I don't. Everyone's got their own standard, right? So it's impossible to say that you're working hard. You're actually working deliberately. I'm working deliberately. I think it's like all up to the guy, all up to the people who are using it. That's why I didn't make like an app that you could use that would track and it would rank your scores with other people. It's because you get people on there who are just saying they work 26 hours a day, and you'll get other people who are like whipping themselves on the back for not like concentrating 24/7. You know what I mean? It's like a whole like different kettle of fish. I have something like that shows up on Discord. What files have been open? Not record that anyway. If you see me 8 hours in near of them, it's only 4 of those actually working. Yeah, yo. Oh no, Emmanuel, didn't you thought you go well? So I'm just gonna head to the loo real quick, because I just realized I need the toilet, and then we're just gonna like dive. You know what we could do is just make sure. I think we should do physics. I think we should do physics all day. I think. This is a really complicated thing, and I don't know how deep down the rabbit hole I want to go for Game is Rigged. Dang it. I don't think. I've got to be careful here that I don't go down the rabbit hole of like writing every single particle physics simulation / effect known to man, doing everything to compress the data, and also doing a full GPU driven renderer the whole time. I don't want to take too long on this thing, right? So they've successfully brought us from the top of the table. Damn. Game was rigged indeed. Right, I will be right back. All right. See you in a sec. You'll get him next time, Emmanuel. You'll get him next time. It'll be an easy dub as well. Easy win. Anyway, so yeah, sorry about like the lack of action right now, but I'm trying to think. Yeah, we need to pick something to do, and yeah, I think physics to me, despite how difficult the rest of the thing is, I think physics I just don't know how to do very well. So yeah, it is updating the subscriber list, but nothing else. Okay, whatever. Minimize everything, thank you. What am I working on? Yes, I'll show you a manual. So we can render 10,000 particles now. I think I'll just show, just for like this, 10,000 particles. We need some kind of physics simulation so they don't look like just a straight line. And this is done in one draw call per instance. We haven't ordered the transparency, so that's why it's kind of like this. You know, ideally it would look like this all the time. You know, so we get like a nice blend. But yeah, we haven't quite ordered the transparency yet. Resolving transparency is actually kind of hard to do. But anyway, so I'm not too worried about it. Now, it goes 10,000 in one direction, which is kind of boring. But yeah, let's do the physics. Let's add some kind of effect to this particle, to these particles, and then we can like increase the amount of particles then, because otherwise we yeah, it's nice that we got 10,000 particles, but we can barely see them, so it's kind of like a complete waste, almost. Yeah. So it's let's hope it's easy. Let's hope it's easy. Yeah, try and simulate a black hole. Yeah. We want to eventually render like 1 million, so I think I've done quite well so far. This, excuse me. It's all GPU driven, so. But for now, yeah, 10,000 GPU driven instances of things is like trivial. So, where is the cloth? That's what I'm after. I'm pretty sure you can do it in a computer. Yeah, I just don't know the system at which. So yeah, so the first thing we need to do is delta time, and then yeah, so let's just say, like, how do I integrate? Let's see. I just want to do a simple, like, let's start off with something simple first. So particle force, physics force, even. So that is the new position, which is, I guess, the velocity. I don't know. D squared is acceleration times by mass times by g, which is okay. That's fine. Plus, and we add the new position. All right, so we'll just kind of steal some code and see if we can, you know, add something. I know this is kind of a bit lame, but I kind of like, I want to get a physics simulation working, and then afterwards, like, get more physics simulations working, right? I don't want to put much effort into this yet. Sorry, the physics simulation stuff. Just because if I put like a loads of effort in and then it like, you know, it doesn't work, then it's just going to be kind of annoying. So I'm going to say 10. I don't really know. G is, so we should get falling, and then we want to say vec 3 position. Sorry, yeah, new position, I guess. And yeah, that makes sense. You can't do that. Yeah, bear with me while I just like slog through a bit of rubbish physics. Yeah, bear with me for a minute. I know it's not. You're gonna see some like questionable maths for a minute. Oops. I don't really mind that much anyway, even if it doesn't work. For gravity, I just want to see something happen, you know. Alright, whatever. Oof, it doesn't like that. That chugs. Why would you need force for acceleration? You need to divide by mass anyway, so you could use G directly. Oh, dude. Afternoon slump, holy. Ugh. I need to travel in a circle, maybe. That might be easier to do. I think the first thing we need to get in the compute shader is a function that's... Oh, is it? Oh, okay. Now you have acceleration proportional to mass. I think what I'm going to do actually is how do things travel in circles? Jeez. I haven't done physics in ages. I'm so rusty. I might open up my old engine, my other old engine. Don't even know if it's accessible. Hang on. I'm looking for this, I think. Yeah. No, this is what I want. I want a core. Yep. Okay, so what I'm looking for is the integrator function. Can't remember where that is. Is it in body? And at least this will like explain the maths just purely without any shenanigans around it. And then we can just, you know, do forces properly, you know. Let's look for integrate actually. Yep. Okay, so we have particle physics here. So you have duration and we have velocity. What does that do? Right, okay. So if we just do the simplest thing first, so we have gravity. We need like a random placement thing as well. Hang on. Oh yeah, for you it's 1640 35. Nice. I think we might need a random number generator. I think that's best to just look that up. So compute based. Compute shader based. Random number generation. So working with Perla noise for procedural generation, I noticed that the resulting terrain exhibits unpleasant repeating patterns. It doesn't take me long to realize that the culprit was the infamous one-liner we have all been using, all been guilty of using at some point. I mean, we could just take a hasher, but okay, so this is the W. Ah, right. That's why I've never heard of this. WGPU. It's Rust. Yeah, I literally don't know anything about Rust. Well, feels like it's part of the good old. You know. Instant index phi and fracket. Do I have access to I need to define it. Rust is Haskell but impure. Fair enough. I wonder what you think of C++. The Satan's language, perhaps. Mm-hmm. Hmm. Okay. Gotta use C++. Yeah, Rust is yeah. All right. All right. So yes, let's look through our particle physics because I did do a load of particle physics ages ago. But this is for like each particle, right? So cumulative force. Okay, let's just do a simple So that's a position. If I take starting position, and I throw the data entry every single thing except for Y. Actually, I'll do Y as well. And then I do so then we take the starting position, no, this multiplied by dt plus what is it? So we take the vector, we add its no. Vec3 gravity. What's this? And then if I look at this again, so actually this is starting position plus times by the scale. That's Vec3, okay, and cool. Oh yeah, gravity in space, yeah. I'm just doing like the simplest thing I can think of. Oh, and this is, wasn't this 1 over 600? There we go. Yeah. Press the F. And what do we get? Huh. Yeah, my brain is just not working right now. It's really I'm really struggling to think. It's really cool thing, but Einstein has this thing called the theory of relativity. Should check it out. Yeah, we'll implement that now. We'll put it in the the physics simulation. Oh, music. Let's put the music on. Oh, where's the music on? Oh, there it is. Let's go. Oh, sorry, it's really loud for you guys. Let me turn that down. About there. Looks good for you guys right now. How's that? Yeah, let me know if that's too loud or too quiet. Yeah, make great. Yeah, literally. Brain is so mush. I don't know why. It just all of a sudden hit me. Oh, I was trying to think. I thought I'd be like, oh yeah, this is the easy part. I feel like I need that hash function that allows me to get a random number based on, hopefully, like a seed. No. You know what? Let's be super lazy, right? Make a new line. Yawn. Let's just see if there's like a quick shader, because I don't really want to. I'm not trying to build the physics simulation that we're going to use right now. What I'm interested in is just like something like that, right? No, where we just like we have like a okay, so that's the classic random number. All right. So this returns what? I just want to see how particles move. Yeah. I'm just really like bleh at the moment. Yeah, it's really cool, isn't it? Have you ever heard of Shader Toy? Like, you get to run shader code. It's actually probably a good idea maybe to mess with it. Oh, thank you, just watching. Yes, you sent me a lovely star. Thank you. So velocity y and x. Because that's all I'm interested in this, right? I just want to set the velocity based on some random number. Which I assume R&D is... Oh my goodness. Oh, struggle. The struggle. Let's pick some songs. I literally feel like I need to watch like a video on like how things move, like linear velocity. I've literally forgotten how it works. This is a cool track. Just gotta fight. Keep yourself awake. It's like I've eaten something and then got really tired. I don't know if you guys get like that. Sometimes after eating something, I just get really sleepy. I mustn't have slept that well last night. Yeah, bit of Crash Team Racing. Alright. What is this? Yeah, I've been poisoned. Alright, I might get some tea in a minute just to wake myself up a bit. What is this? Computes the fractional. What's the fractional part? What do you mean the fractional part? All right. Fun fractia. I don't know what the fractional part. Oh, I see. It's the that'll be the ending, right? That'll be the modular. All right, cool. No, wait. Right. Okay, so that's how you do the mod. The fractional part is the part after the decimal delimiter. Right, okay. So I sort of... Oh, okay. That's good to know. So if I had 0.256, it'll be the 0.256. Okay. I've started to wake up a bit. Just about. I'm not gonna lie, it's gonna take me a minute though. Fractional part of the Mantissa. Yeah, I think it's the what's the Mantissa again? Yeah, I've been poisoned by some grapes I ate. Yes, we need to at least get this. This is the beginning. So this is a random number. So let's just see what it does, right? I'm gonna play around with this because we need to basically start placing these particles in random places. And we saw this earlier, so this seems like a function that like kind of everyone uses. I don't know what this co means. So it returns a float. So what I'm gonna do is just like make 3 random numbers with this, right? And I'm gonna do like 1F, 3F. I'm just gonna see like, okay, before we do anything, we need to have like random numbers. We need to have some randomness here. 3 and then like 5. So we need like rand 1, rand 0. So 1, 2, and what I'm gonna do here is vec3 0.f. It's not the meant to say. Oh, okay. It's just whatever's after the decimal. Yeah. So rand 0, and right. So let's just see what that value is. So I'm just gonna play around with the values for a bit. Oh. So I'm gonna change the instances. I think I'm also gonna clean up the code as well. That's gonna be like an easier task to deal with. Yeah, let's before we continue, actually, I'm kind of curious to see. Yeah, this is gonna be like because like I said, I'm like basically, I feel like I've had like a lobotomy right now. I don't know why my brain is so like dead. So let's just do something a bit simpler, right? What I'm gonna do is go to here and just kind of see like, okay, considering that rewrite we just did, like what actually was the difference between these two files that caused the issue. So that's what I'm gonna do. So I'm just gonna do a little bit refactor and then push probably before we break anything. Source graphics, what was it? It was Yeah, particle renderer and new particle renderer. I don't really understand what the difference was here that caused like the issues. So particle date was in here, and okay, so new particle renderer has some changes that need to be made. In fact, yes, let's do this, and then yep. I'll do particle, that's it, and the rest I can keep. So let's go to a new particle renderer. Did it save? Okay, so that was a waste of time. But yes, at least I know what to do. So let's yeah, so there's some leftovers from this being called 2D something. So particle creation pipeline. Pipeline, yeah. Alright, cool. And this needs to be changed to particle pipeline. And what else? So we have right, so oh yeah, we have instance count we need to get rid of. So yeah, I want to push this, but I don't want to like push a bunch of stuff I don't use. Not for this anyway. Let's just make sure the changes we made haven't broken anything. I don't think they will. Oh, the computer shader stuff. Hang on. Right, whatever. Let's just see what happens. Okay, interesting. Seems like it's a random value between these two values because we've got like some dot products happening here. It's actually kind of cool. We need to like rerun this multiple times with a different value each time. So what we need actually is, how do we run this multiple times? Wait, they all ended up the same value. So even if I did like this, I don't think that makes any sense. Because they're all just going to be the same value, right? Yeah. And I think if I rerun this again, it's just going to be... Yeah. Maybe... No, that won't work. Anyway, let's keep investigating this difference. So we have an author... Yeah, okay, so... Yeah, we can get rid of that. Thinking about it. Yeah, new particle needs to get rid of this camera. Because we never use it. And that is going to be an efficiency for cache locality. Because we're not initializing this matrix anymore, and really this doesn't need to be here. As far as I'm aware, we don't have to do this either. Let's just make sure that didn't break anything. What I'm going to try is just something a bit mad, right, with the shader. Yeah, let's try data count in here. Let's just see how this behaves. Oh. Interesting. Right, okay. What about now? Okay, this is probably just going to go completely cuckoo. No. Oops. Sorry, I didn't quite see. Right, okay, so no idea what's happening there, but anyway. Kind of interesting. We are getting some variance, but it just seems like it's increasing by... Anyway, let's go back to this. What else are we missing? Reload. So it looks like the only actual issue that we had where we weren't uploading the particle set. Now, the truth is we don't need to do this every single frame, so this is actually bad. We're uploading it every single frame for no reason, and I think, as far as I'm aware, we can get rid of that. So, yeah, you see this happening every single frame. That's because it's CPU. It is host visible. But really, we just need it to not be used at all. We'll see. Yeah, okay. Because we're never going to update the particle sets. Yeah, so we get rid of that. That's a mild efficiency gain. Reload, and oh yeah, pipeline, I guess. And yeah, maybe this should be called particle sets. Yeah, so let's get rid of this particle. This should be particle pipeline. That's correct. Okay. And obviously particle pipeline. Now, I don't think we use these at all, so I'm just going to get rid of them. If it doesn't compile, then it doesn't compile, because then we know we're actually using them. Okay, we are. But we're using them outside of here at all. Oh, yes, okay. So, yeah, that's actually quite important then. Oh, wrong file, sorry. Anyway, reload. And, yeah. Oh yeah, particle sets I probably want to use because that is more accurate. Oops, wrong file. Yeah, I still don't know why this works versus the other one, but anyway. Ah, that was a mistake, I think. Particles, no, that's fine. Particle sets address. No, this is particle set because this is one. Ugh. Yeah, lobotomy Ultramax, Vulkan devs, I feel that right now. Feels like I've eaten like lead. I ate lead and mercury for lunch. And now all hell is broken loose. How you doing, dude? Good to see you, beast. Alright, so that goes there. And yep, and what's wrong with this? Oh. Right, so particle sets, yes. Many heavy metal yummers. Yummers, indeed. Yeah. Got a heavy metal max. Yeah. Considering heavy metals are more valuable, it's actually called value maxing. You don't want to be a light metal chud. What am I even saying? Yeah, that needs to be... That's wrong. This should be particle set. I do like that being called particle set. Particle set, particle set, particle set. Because it is like one. The particle sets is the array. And now we shouldn't have any issues. That's it. Chud, lol. Need to get Mac to metal max Sag, yeah. It's a disgrace. Anyone who is in metal maxing. Yep, we're still getting that, which is fine. And if I look at this one more time, there isn't anything in here that's particularly outstanding. We have particle set, but I don't think it's used. I think that was a mistake. It's just a name difference now. And what the word should. Sound cute saying the word should. That's probably not what you meant, because that doesn't make any sense. Oh, I love it when you say the word chud. Can you imagine? You gotta remember, I'm limbotomy mode right now. Man, I have a new girlfriend and she's terrible in every way, but when she says the word chud, man, I'm just, it makes everything better. Okay, so everything's fine. Render blur. Yeah, let's call it render blur. Yeah, this is called a render blur. When you say, oh yeah. Ah, okay, right. Chewed. Chwida. I don't know. Just got recommended the manga guide to microprocessors by a friend. Interesting. That might be interesting to like. Yeah, there's a lot of them, to be honest. They do exist. Those manga to like do teach you something. It is like as far as I'm aware, they're kind of like as a fun activity. Right, okay, so now I am going to remove the old file. Oh, there's loads. There's lots of manga guides to something. Like, I'm not even kidding. Like, there's loads on, like, learning Japanese. There's, like, manga guide to learning Japanese. There's, like, multiple volumes of that. That's, like, written in English and it slowly goes to Japanese. I think there's like a manga's guide to drawing as well. That's the one I'm familiar with. But I I did then learn later that they started to make like different ones. I think they sell quite well. I think they make like a good fun gift, you know. Alright, so let's get rid of this. Rename these two. And obviously the okay, we've done that. Now obviously Visual Studio is going to complain. Yeah, if we're going to commit something, I think we can finally fix this issue for once and for all. So the problem is we went to into tabs briefly, and it kind of made everything look ugly AF. Fun in this economy, yeah. I feel like that, yeah. There we go. Tab this over. I'm working through a tour of C++ by Bjorn Strawstrup to strengthen my C++ skills before going back to Vulkan. Fantastic idea. Fantastic. New tab. Yeah, it's you do, like I said, yeah, you know that roadmap I've got on it's almost like I don't know if this will make sense. I wonder if you guys would like this. Like, I've been tempted. I'm not going to do this idea, but like, for the people who are learning C++, not like the advanced people in chat that always tell me that, you know, doing something wrong or, you know, pointing stuff out. But like, you know, for the people who are actually like learning stuff, it's like I've been tempted to like give you guys like an interview after you've learned your C++ to see how you stand, and see what you could work on, like a junior level interview, right? So you can feel, and the idea wouldn't be that you know everything that I'm going to say, but you would be okay if you get like a 70% on like all my questions, then you would be like pretty solid to literally do whatever, right? And it would be based on that list that I sent in the roadmap. The I think I've talked about this like an infinite time, but this thing, right? You know, the interview would be on all this stuff. Like, I wouldn't know how to do something for outside of Visual Studio, so I wouldn't be able to do the breakpoint thing, but maybe I could ask some like basic stuff about how programs work, like what's the program counter, yeah, what is a breakpoint, you know, static assert or something like that. You know, just give you guys like a little bit of like a, because when I say there's the barrier to entry here is not, it's not like you need to know all these. You need to know these at some level of depth, but not to the level of depth where you have to know everything, right? But it's like what a junior level would want for, like, you know, when would you use dynamic cast? And he'd be like, you would have to tell me why, like, when is it better to use dynamic cast versus static cast, and like, you know, why is it a good idea to do this, etc. Like, when can't you use const expert? You know, that like questions like that, like not that complicated, but still necessary. Anyway, become CJ but less shitty. Yeah, like yeah, like not putting people down or only picking the worst interviews. I don't know. It's kind of keeping the level of complexity kind of level where it's like, I feel like CJ kind of goes off on like a tangent. It goes like really complicated down like one direction, and it's like, yeah, kind of, but like, if you want to build software, you don't need to know, like, I don't know, how to you do structured binding or something random, you know, like this is enough, right? You don't have to do like, or what is the difference between a, you know, like, name all the different forward iterators, and then tell me the why some data structures don't have, like, there's like, yeah, CJ sometimes does like questions that are a bit too complicated, I think, for like, they're like unnecessarily difficult. But then again, maybe he has like a community of people that like love C++, so everything would be super basic. And if you get to know what I'm talking about when I say CJ, there's this guy called Coding Jesus, and I think he got popular, or relatively popular at least, doing coding interviews. But what I'm talking about is like a much more like a realistic, almost like version of that. It's not like maybe his experience is very different from what my experiences were, but you don't get drilled on like the stuff he talks about. And then, you know, if you don't know something, then the interviewer will just move on. He won't like go on and on and on about this thing until you know what I mean. Like it's a bit different from my experience, but maybe in the quant space it's very different. I've literally no idea about the quant space. Yeah, I mean, I like them. They're like a nice kick in the butt sometimes. But I think it's just like for like new people who are like just starting out, who, you know, let's just say you don't know something in the lit, like, I don't know, let's just say you mess up something like, I ask you what capture clauses are on lambdas, and you're like, you completely don't know what I'm talking about. It's like, all right, yeah, you don't have to know literally like everything in lambdas, right? You can like know what a lambda is, and then like, okay, right, maybe something you could study is lambdas, right? And then we can move on to say like, you know, how does the single pattern work or something, rather than being like, all right, you don't know lambdas, all right, let's just drill lambdas to death then. So anyway, that's what I was thinking. I like doing that. I don't know if I'll do it on stream, but or just like any Discord call or something. I've literally no idea. But just give you some guys like where you need to be to like start coding Vulkan. Because the idea when I say like the barriers to entry to this is so C++ isn't an obstacle for you. It's like a tool, right? That's like the reason I'm like asking you to learn all this stuff. It's like, so when you are learning like a Vulkan, like you're not stuck on some you know, C++ thing. That's like the whole point of like giving you like a limited amount of things to learn, rather than like learn everything in C++. Be right back, eating. What even is quant anyways? Lambda is my domain expansion. Lol. Quants, I don't know if you're actually saying it as like a jokey philosophical question. But yeah, I'll answer it seriously anyway. Like quantitative analysis is like how you do stocks and trades and stuff. So you already know what this is, but I'll explain it for people, I guess. And yeah, you can get like a really high-paying job if you go into quants. So my main problem isn't actually C++. It's the math stuff. Basically ignored it all my life. Ah, I see. Yeah. Yeah, that's tough, that one. Yeah. I thought quantum every single time. Oh, actually, you didn't know, yeah. Yeah. Yeah, it's so when you're a quant developer, you're writing software for the trading firm to do, you know, X, Y, and Z trade stuff, right? Anyway, right. But yeah, if I was to do it, it would be like a tiered system. Like you would be, like the interview difficulty would ramp up depending on where you are. And at some point, you know, I wouldn't be able to interview anymore at any level, because you'd be at my level or above. But generally speaking, it would be like, are you ready for learning Vulkan? Then I would give you an interview on C++ or something. And it's like, okay, are you ready to start, you know, building a game engine? I give you like Vulkan quizzes and like 3D maths and, you know, like other stuff on top of stuff. I don't know. It's something I was toying around in my head anyway. Oh yeah, let's get rid of that. So we don't need indirect. Okay, so literally everything's the same. What is the difference actually over there? Is it just white space? Oh yeah, it's just that. Okay, let's fix the shaders. So we don't need this. Yeah, maybe it's something I could do for the, you know, hypothetical, what is it called? You know, Patreon/coffee thing that, the idea of kicking that around, you know, like something to help you guys out or a bit more. They want to help the stream out. I don't know if I'd do that though. Again, it's a bit of an idea, or concept, you know. What do we actually need here? Right now I couldn't even pass my own interviews. Flipping heck, I feel like I've literally got no brain cells. Yeah, I thought we already did that. Hang on. We got rid of that. Oh, I didn't save. Okay, so we just need... I thought you needed that for... Alright. That'd be really good though. I'm gonna hit you up when I'm done with the books. Yeah. Yeah, it's gonna be well, we'll see how it goes anyway. We might prototype it one day. I don't know. See how it goes. So yeah, I'm gonna get rid of this and then make this a new particle renderer and then kind of paste that in. Oops. Right, so we need to regenerate the project. Yeah, because there's a lot of other stuff like like when you actually go for an interview, they'll ask you stuff like, especially if you're new, like they'll ask you stuff about Git, and there's stuff like that people don't think about when it comes to learning stuff. Like how do you you know, handle your projects? Like what's your project management schedule? You know, when it comes to like general development skills, right? There's not just like how much of the C++ standard have you memorized, which I think, you know, is not that useful, to be honest. Alright, so what I'm going to do here is just comment out some stuff and just kind of throw in my crappy you know, C makes another one that you might get interviewed on if they use it, but I think that's not as important as something like Git. So yeah, there's like other stuff. Yeah, oh yeah, that's a good point. Let's get rid of these, which is kind of good job I compiled. Yeah, okay, so that's good. And I also think... Oh, is that... Yep, okay, cool. Oh, someone sent me a resource, thank you. Who sent me a resource? Huh? Okay, so that should be the one that with the particles going off infinitely. Basically 10,000 of them in this direction. Cool. Very nice. And I think I'm going to commit this before I do anything else, because at the moment it's in a decent position. We have particles rendering. We have multiple particles. Oh, you goes pin by accident, no problem. So I think I'm good. I think if the refact is done, we don't have any silly shenanigans going on anymore. I'm going to get rid of these two, because we don't have a GUI yet, so right, okay. And we should see everything the same. Yep, off it goes into infinity. And what I'm going to do is git add, git commit, got particles began. Sorry. We have the beginnings of a GPU driven renderer for particles. Right, so some changes. We have 881 insertions and 614 deleted. Very nice. Big change, big change. Right, okay. Now, compressing the data is not that important. We just need to have... Alright, so what I'm going to do is... I am going to just head to the loo real quick. Hopefully by that time I've gained a few brain cells back and I can actually continue to code outside of refactoring. If not, we'll have to just do things until I don't know how to describe it. I feel just extremely tired, but I know that's just because I've eaten, so I'm starting to wake up. Anyway, right, I'll be right back, guys. All right, see you in a sec. I'm back. Alright. Alright. Let's pick a different song. This is a good song though. I will leave it. Alright. I guess I change up this chime when I finished. Okay, so we've committed our GPU-driven particle renderer thingy. We have no physics in the compute shader, so we don't actually simulate anything. And that's what we tried to do originally, but my complete utter lack of brain cells just kicked. I don't know why. All right, so yeah, obviously we can just copy and paste this whole shader, which would be bad. But what I'm interested in is not necessarily how they do their thing. What I really want to find out is how they integrate over time, right? I think that's what I need to look at my own shader, to be honest. Let's look at my own compute shader. Now I feel like I've woken up a bit. I'm not back up to standard yet, but I think I at least can concentrate a bit better. So we need to get a cloth because this integrates over time, but I want to know how it does it. Like how, that's the most important part for me. It's not even necessarily the physics, it's like the basic stuff. How are we integrating over time here? So we are setting variables to this new position or whatever. Update their position. So I think for each vertex count we do this for every single thing. Okay, so this is fine, but it's also like cool. What do we want to do with this, right? And we do have a random number generator-ish thing. And so previous position, current position. Okay, so this is probably set in a wider for loop. So this is like basically written as if it's on a compute as if it's on the CPU, I think. Right, so let me think. How are we doing an integration here? In a compute shared with thousands of threads running. That's the confusing part, really. It's not necessarily the maths, it's also like, oh, by the way, let me say that again. Like, we're doing thousands upon thousands of like threads all running this simulation. Like, how on earth does this simulation run without completely breaking down under multiple conditions? Now, obviously, when we run an instance, we have basically an access to, in our code, we have access to like one position buffer, right? That needs to be set. Now, it doesn't matter if we multiply by dt, for example, if we have like... Right, I'm just going to talk through this a little bit, so bear with me just for a bit. I don't actually know the answer yet, so I'm just going to talk through the problem. So I think that's like a nice way to think, right? Osity. Yep, still less brain cells than desired. Okay, so let's just go with... I'm just going to do it like 1, 0, 0, right? So it moves in the X direction. Eating meat with rice right now. Yo. Love that. What's the meat with rice meal called? Or is it just, I cook some meat and put it on some rice? The meal. So if that's the velocity, right? Now, if I just do this, right? If I have like what? float delta time equals 1 divided by 600 dot f, right? If I just multiply that by dt, we don't really get any change here. We don't really get anything interesting. We just get like a, and then I set this to position, right? And we could say the starting position for each variable is that, so that's fine. If I take that and say add our delta time to it, we just don't get anything interesting. It looks like it's moving, but that's just where my camera is sitting. I think all we've done is literally moved everything to the right slightly. Generic white rice with some meat on the side. Yo, that's actually quite tasty sometimes, to be fair. Like really nice white rice. And then like a cool bit of like a good bit of meat. Yeah, I can appreciate that. I can appreciate that a ton, actually. Because there's no the problem is there's no like delta, right? This is like a pretend delta time. Oh, look at that, your #1 fan all of a sudden. Look at that. Okay, what the heck's going on here? Yo, Gemma, how you doing? Glad you're back. Oh, you've the auto translator's trained you to yo. There we go. Hello, Mabdo. I want to say top of the morning, even though I'm not even. So I'm just gonna say it anyway. Top of the morning to you. I love meat so much I could never be a vegan. Yeah. Same. It's not very good. Oh, thank you for the lovely 10 gold coin with the. That you spent 10 joules on. Thank you. I'll just, again, because the bot isn't working, I'll bring up the chat and say, look at that. Thank you very much. Right, okay. I am going to get rid of this. Okay, so we need... Okay, so how physics works is obviously... calculus works with like what limits, and that's like the original definition of like how to do derivatives, right? The problem is we don't do that in computer science because that's impossible. We have to like basically estimate by getting extremely close. What we need to do is we need to come up with an idea for like how do you do delta time. Like, as far as I'm aware, it's not the physics we need to work out. It's the first part. It's the okay. So this is dt, right? Yeah. And we have steps that go over this. But like, how do we say like, oh, the previous step was that, so this is how much time has passed, and then we can like we can move the physics simulation like further down, if you know what I'm saying. Like we've moved X distance, now we can do Y thing, right? The problem is I don't really understand that. Like, how do we get delta time, basically, like true delta time? It's tough to, well, it's not tough, it's just I just don't know how to do it right now. It's not like we set delta time anyway, do we? That could be it. But that would have to be shared data, and it would be kind of awkward. I just don't understand. Doodle doodle. Because we do physics all the time, right? Like, literally. Like, what I mean by physics, right, is if I just run the code and I move around, right, This is physics. I'm literally doing physics. This is linear integration. But, you know, how do I do that in a compute shader where I don't have any concept of a timer? That's the question I don't quite understand. And let's go to this render toy thing again. Like, how are they getting the time? Right, that's the first thing I should investigate. So this should... Okay, so this random numbers, random noise. Yeah, I time. What's I time, right? I time. Whoa, 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 whoa. Okay, so it's just lit up. That's fine. I time. What is I time? It's just a used variable. This might be in a. I mustn't. What? I'm confused. Ah, right. Yeah. Yeah. I was just about to think that. I was like, maybe this is a shaded toy exclusive thing. You have to get the time from the CPU. Boo. That's not good. I mean, it's not the end of the world. It's just not ideal. Automatically sets time for you. That makes it. Thanks for that, TT. That's very helpful, actually. All right. So what have we got in here? Compute shit. Interestingly, like, how did I do it then? I must have done this somewhere. So your position, start position, end position, velocity, mass, force. Yeah, that's just all that kind of stuff. Where is the delta time? I'm confused about this. This was done in a very strange way, I have to admit. Increment a number indefinitely. I mean, that's effectively what kind of the global timer is, but that's not quite what we need. Hello, escape points. I'm, yeah, 5090. Yeah, I still owe someone a 5090. Yeah, I don't think there's any times on the GPU. So, yeah, I think you're right. Which is unfortunate, but inevitable, I guess. I guess it keeps all the CPU... I guess it keeps the... Yeah, because let me show you guys. I almost need to do this for myself as well. Just so I know to do the right thing. So, ooh, I'm gonna be low here. Right, so here, this is the handle events. Then we've got some other handle event stuff I've commented out. And then we go, okay, so the current tick is this. Then we just get the delta time between the two. So we have delta time, right? And then we can update the physics with that, which, you know, if we look at that, what that means is like, okay, in this case, we don't actually use that because of a physics thingy. But outside of that, right, you know, we use this in... Here we do like a multiplication here, and that gives us the yaw and pitch. But even that is used in, you know, for the speed at which I haven't played Sekiro. I've watched a good talk on it though with the grass and like how they did the grass, which was really interesting. From the OS2 API thingy, yes indeed, it's all thingy today. I'm still recovering from lunch. I feels like I've also please use fixed time steps. Hello everyone. Hello. Thank you for all joining us, by the way, guys. It's always nice to see you all. I hope you're all having a great day. What have you been up to? Hi Kalia. Okie dokie. Fixed time. Yeah, I don't use fixed time set, admittedly. Oh, Ghost of Tsushima. Oh, sorry. I got them mixed up. Yeah, excuse my brain right now. I don't know. It's just it's half working. Yeah, I am thinking of that talk, the grass talk, literally. Oh, jeez. Right. And in other engines, I have done similar things. No, this is a little bit more dense because there's way more going on here, but update game, send up the view thrust in planes, which we might do. I feel like it's easier to do honestly right now. Oh, this would be the is this render? No, this is the physics. So like update animation takes in delta time. And yeah, let me just pass through some code so I can re-figure out. Oh, actually, we can also look at the older engine and see duration is the time. As far as I'm aware, if we have delta time, right? I do not have a PS5 now. Yeah, it's one of the things I'm lacking. Gotta love how a talk about grass is popular enough that people automatically know what you're talking about. Yeah, exactly. It's a really good talk, to be honest. Yes, have you heard that talk about grass? Who hasn't? Yeah, so if the delta time is that, we just added to... Yeah, okay, so... So if I was to say a fixed time step of 60 FPS, which wouldn't be good. Okay, so I'm going to kind of steal this idea and just see if it works, right? Yeah, just bear with me. We might need to do some... Yeah, touch crash indeed. PS5 is trash. Well, I don't really have any strong opinions either way. So if I have a scaled vector of 1, 1, 1, and we take that vector, multiply by itself plus itself. So hang on. So we set this up, yeah, like that, right? Then we take velocity, multiply it by delta time, and it's equal to velocity, right? Let me look at that again. So vec, no, it's plus another one. And if you go back 1 minute, so this is the position. So let's get position. Vec 3. Yeah, okay, so let's pull this out. If I can get some kind of physics done today, I'll be happy because my goodness, my brain. So yeah, just bear with me while I'm being a bit dumb. So we have two vectors, right? Now, if I want to do that, so position equals, so plus equals velocity times delta time equals that, and that equals position. I don't know what that means. Let's go with negative, actually. The reason I want to go negative is because that means it would just go off in the direction it's already in. So we throw this in here. Assuming that works. We'll see. Your voice sounds exhausted. Yeah, I'm very tired. I don't know why. Also, people have been burning like rubbish, and it's just like, ugh, it's got in my throat. No, you don't want to move. Right, let's just look at that again. Hang on. Nope. Just increase the speed, perhaps. He is exhausted. I was doing something. I sent him a pic. I sent you a pic, escape point. I was doing something. I sent you. You spent a lot of time on that project learning. Yeah, that's true. I think you are right, Cal. Yeah, it is. I am learning a lot. It's one of those. All right. What are we doing? I am struggling with this because I don't exactly know how. It's so confusing. Like, how do you do compute fit? Like, I've done it before, but I don't. The way I did it before, by the way, is I cheated. Oh yeah, you might be right. Yeah, I think I am actually. Yeah, I think that's the mistake. So obviously that's not going to work, but if I put this at... If I just have a... You know, 111, I don't really care at the moment. Yeah. Is that going to work? Okay, flung goes around in circles. Oh, okay, so the frame rate is super slow on that. That's me moving my mouse because I'm really close to the object. It's the transparency that's causing that to go slow. Why didn't you use HLSL? No reason. I just know GLSL, that's all. There's no like better or worse since. At least take 2 days off. Maybe. Yeah, maybe you're right. Maybe I've gone a bit hard recently. I just need more sleep, I think. You can calculate it from accumulated time if you need to not persist position. You can calculate. You can calculate it from accumulated time. Yeah, because what I'm confused by is you multiply this by delta time, and then it's like, all right, yeah, that adds to the position, so you move it. I think what I might need to do then. No, it is changed every single time. Yeah, it's been 5 hours. Yeah, I think I just need more sleep. But I also am practicing something. This may seem a bit odd, but like I want to make sure that even when I'm struggling, I keep pushing. Because it builds in a habit of, despite the fact that I'm not at my best right now, it builds in a habit that I start to give up as soon as I get tired, right? Whereas like it might be a good idea to keep going in some situations, even if I'm tired, especially because, you know, it's like, what, 4 o'clock for me. You know, I should be okay, but something's made me tired. I think it was it's a factor of a couple of things. So I'm gonna, what I'm gonna do is just like investigate how compute shaders work a bit, maybe. Because like, at the moment, I feel like I'm missing something. So the execution model operates differently from other shader stages. Yep. All of the other shader stages have well-defined set inputs values, some built in and some others user-defined. The frequency at which the shader stage executes is specified by the nature of that stage. Vertex shaders execute per input vertex. I don't know what do I need to work on right now? Right, I could just like research this, but I think what's going to end up happening is I'm going to kind of going over what I already know. If I just want to do physics in a compute shader, but if I have a fixed time, can't I get away with this with a fixed time step, guys? Like that's what I've been thinking, right? Well, if I just define a delta time that isn't frame rate dependent, I can just say, oh yeah, it's 100%. This, for example, let's test this. Let's test this out. What I'm gonna do is, okay, forget this delta time thing. What I'm gonna do is, I'm gonna say that float delta time is equal to 1 divided by 60, right? I'm just going to do 60 FPS. Like, what happens to the actual game if I do this? Okay, so yeah. It's way too fast, hang on. It does work, but you need extra logic so the FPS doesn't affect the time. But forget testing, it probably doesn't matter. Okay, that's way too slow. Oh no, there we go, that's like normal. You see, right now we've got this problem, right? It's a bit too wavy, that, to be honest. You know what I mean? Like spin around a bit too lackadaisically. Yeah, and trying to render 10,000 points all at one point does make the frame rate go to poop. And so you kind of get this like horribleness going on. And I guess if you bring this back, let me just see. This is actually quite good, actually. I've got this here right now. Because now we can see. Now we can see the difference, right? So, where's the duck gone? Oh, there it is. Am I upside down? I feel like I am. Okay. There we go. Nope, still backwards, but that's fine. Where's the... There we go. Okay. What the heck? Just shot past it. Yep. So that's what happens right now when the frame rate goes slow. It goes because it's using delta time. So it's still like measuring. Do you see? Do you see the difference? Like we just shoot past it. Oh wait, do we? As far as I'm aware, anyway. It's like a black hole of graphics ability. But if we have a fixed, like, oh, just do it every single. Let's just try it this way. You know, if I was to... I'm pressing W right now. It doesn't matter like how bad the frame rate. Oh no, I'm lying. It's exactly the same. Ah, we got into the black hole. Rawr. That might be actually the billboard's fault, to be honest, because as soon as you go through it, you don't render anything. Right, okay, I think that's what it is, actually. More than that. Okay, so, even if we... Okay, so we pass in... I mean, I could pass in the delta time. I don't really have any qualms against doing that. I just don't really see the difference. Because I can just fake the delta time in the compute shader. And yet, we're still not getting, like, any movement at all. Do you know what I mean? Like, we've seen that this does something, and I believe, as far as I'm aware, if you take a vector and do that, like even if I you know do it twice, I guess, like I don't know if it needs to be d squared, right? But that's acceleration now. I'm super scared of black holes. Yeah, it's scary if you're scared of the dark. Oh. I just need to move away because it's rendering one DOS. Like, it's just staying still. I just don't get it. Oh, am I resetting the velocity? No. That would be the... That's fine. We're not doing it. We're adding the velocity. We're adding the position. We're not resetting the position at all. And that's the thing I don't understand. Do you see my problem is, by the way, or am I just like, do I sound like a nutcase? I'm just change this to blue so it doesn't lag as bad. Okay, it's just bad actually. Yep, all my positions are 1 1 1 1 1. Can't you read from the current buffer? I'm writing to the current buffer at the moment. This is the positional buffer that sets the positions. Yeah, I think there's some shader stuff I just don't quite understand. I'm just trying to figure out what I need to study. So let me think. So compute shaders, yes, but that's so what we might do tomorrow if I I might get like a real attack at like understanding this stuff so we don't get stuck. So you know, I say like I know. Hang on, let me pause this for a minute. You know, I was saying to people like, oh, you should learn C++ so stuff doesn't get in your way. This is like what getting in the way feels when something feels like it's getting in the way. Like something is getting in the way here, and I don't quite understand how to get past it. Anyway, so but positions should be read from the buffer as well, not just 1 1 1 1. Otherwise, you'll get so I need to read, sorry, I need to write into a buffer and read into a buffer at the same time. Okay. Yeah, okay. I can see that. Let me just rework some things. If I'm gonna do that, I'm gonna have to change a couple of things around. So I need like the previous, like what it was previously, and then we can work everything out properly. Right. Okay. So we can try that out. Okay. So that's gonna take some pipeline changes. Because it was only write only. Because I thought we could just write to it, but yeah, that makes sense if we're trying to do something from the previous instantiation of the object, we need to be able to know what it previously was. Alright, so that buffer was called... so we... Okay, so it's already read right, it looks like. So we can actually read to it. So if I take the positional buffer from the previous frame, like this. Right, I'm going to change the music real quick. I think we're just getting repeating music. Old position. Alright, sorry, I need to pick like an actual new track. This will do. And then we take, no, that's acceleration. That's velocity. We take old position, and that equals new position. Equals this, right? And then, right? We'll see, we'll see. I don't really care if all of them are moving at the same time. I just need to see them moving. Yay! Thank you. That was really helpful. We have movement because I knew the basics of thumbing. Thank you for that. That's actually really helpful. Now... Okay, so should be... so plus equals should be plus... Should be just a plus. Where's plus equals? Oh. Oh, yeah, I didn't see that. Jeez. Thank you. So, yeah, if we do that again. Yeah, off he goes. Bye-bye. That's remembered by persistent. Right, cool. I'm slowly awakening more brain cells, so that was probably my fault, honestly. TT. Yeah, it just clicked. Thanks for that. Thanks for trying to help and helping as well, and obviously, I got there in the end. Right. I don't know what the old position is if there's no position to begin with. You know what I should maybe do is randomize the position. For fun, you could set a velocity dependent on index, and that would move them off in all directions. That's what I'm actually trying to do, something like that. So velocity based on index, what would that mean? So obviously this would just, they would increasingly get faster in multiple directions, but that's not what you mean. Let me think. Right, whatever happens, I'm definitely going to bed early tonight. Right, so I'm going to, like, say, get a random number from... Random hash... No. Yeah, we need a hash value. Hash compute shader function. These exist. There's like a simple function that everyone uses. I just don't know it. I've seen even Ace Roller do it. He's like, oh yeah, everyone uses this function. This is just... I think it might be worth... Yeah, I think it looks something like this. But it's not... That's not complete. I mean, we have these two values here from random, but I don't really understand what this code means. So what I'm going to do is just work my way backwards. It was mentioned somewhere, the... you could use rand, you got a random in your shader by look. Yeah. I just don't know how to use it, to be honest. Like, the input is this value. And I don't, like, if I just throw in, for example... Yeah, let's just try it, right? Let's just try it. Let's try and get 3 random values. Yeah, we can do that. So I'm going to do it slightly different, but that's like really cool. So I'm going to make it basically more explicit. Float. Rand 0 equals random. And then, yeah, we're going to do a vec2. Yeah, 0 to... I'll do the same thing. Data index. And... yeah, we'll just kind of obviously change the values a bit. And I love this song. I don't know what that would be, the next one. Maybe we'll just do half and half, perhaps? I don't know. I know that would be the same as like these two. I have no idea, to be honest. Yeah, let's just put like a random number in, I guess. Just like the same random. I'll just leave it. I'll just put like and leave it. Yeah. We'll do 0 for this for a minute. One, 2, and 3 instead of 0s is fine. Oh, and oh, okay. And these. We'll see what that does. Oh yeah, they all are going in random directions. It's really random. Holy. Remember, they're not ordered. And I've only done it in... Alright. To speed it up a bit. Let's put rand 1 in twice, I guess. It doesn't really matter. Is it a volume they're filling up now, or? Oh yeah, because they're all going off in one direction. Oh no, it's just along one axis. So we need to make a new random number. Okay, so duplicates rand 2, and then I'm just gonna kind of put this between. I don't know, the random 1 and random 2, maybe. Maybe these are going to be like different enough. Kind of like make another random number out of random numbers. Let's see what that does. Because they are going to be different from each other. Yeah, okay, that'll do. If it's a volume, anyway. Yeah, that's fine. Alright, so let's increase the speed a bit, which is pretty easy to do. As far as can I do like 100.f? Yeah, that's kind of cool. Just expands out. I mean, it's obviously all uniform, but it's kind of cool. Obviously looks way nicer when they're not all separate. Sorry, when they're not all together. Almost looks like a space snow. Okay, maybe 100 is a bit too quick. I'll go with 50. Yeah, the reason I wanted to do this is so I can like push the renderer a bit. I can't really do that if they're all in just a straight line. Yeah. Maybe we could do something like a cyclical, like, random number. Like do sine or something. I don't know. On one of these values. You could subtract 0.5 from the velocity and then normalize it. You would become a sphere. Is that from velocity? Let's see. So if I did what? Minus vec3. Sorry, I'm a bit like out of it at the moment. So thanks for bearing with us, guys. And then take all that, normalize it. Oh, before, okay. Yeah, okay. Vec3 0.5 and then normalize that mofo. Meow. Meow. Alright. Let's see what that does. Oh shit. Sheesh. That's sick. Yeah, that's a proper sphere, that. If I didn't normalize it, would it just be like a volume? That's really thank you for helping me with the maths, honestly. Yeah. I'm not that strong on this stuff, so it's always appreciated. I think I'm gonna practice this tomorrow. Yeah, it's pretty cool, isn't it? What does that do? Oh. Okay, so they're just kind of like going off in their own direction. Alright. The reason I wanted to do that, by the way, is just to see if I could increase the number. Oh, yeah, you're right. Did I mess... Like, where is everything, actually? Yeah, okay. And then... Alright, if I got rid of... Hang on, I would need to... Yeah, I would need to do this without the normalize. Anyway. Now, what does that do? Okay, yes, that's it. That's kind of what I'm... That's kind of what I was after. Not because I... I don't know. The reason I wanted to like just do a massive explosion is because I need to increase the amount of particles I'm doing. If okay, now multiply. Now you just multiply the 0.5 by 50. Okay. Oh no, a cube. You're right. Got ya. Right. Okay. So the reason I wanted to do this is because I wanted to put particles all over the place. That's 10,000 particles. Next thing I wanted to beat up was okay. Or instance count reaches 10k. Oh, 10,001, I guess. Wait, hang on. If this is greater than or yeah, greater than 10k, you want to do another draw call. But the problem is this global invocation is going to get extremely large. So I need a way to kind of like reset the instance count that we're doing. So I can do like 1,000,000. Otherwise, you can't instance draw 1,000,000 things. So let me think about this for a minute. So I just need a bit of logic here that's gonna kind of like reset this every single time. So the idea anyway would be to every time we create one, we set the instance count to 0. Now obviously what's going to end up happening after this is global invocation is going to be, you know, 10,000 plus 1, which is not correct. So effectively we need a formula to kind of clamp. We need a clamp, right? So yeah, we need to clamp it. We need to clamp it between two values. So I can't remember whether it's starting and end, but I think the end is first. So, no, there's 3 values, isn't there? There's the actual value, and then the 2 values it's clamped between. Something like that, anyway. So I'm just gonna look it up. So we need to, yeah, we just need to clamp it between 2 values, otherwise it'll just get increasingly big. I just don't know the syntax. So the actual value, minimum value is first. And the syntax highlighting does not help at all. So yeah, minimum value and then max value. Now, that should... Okay. The problem is, if I set it to 20k, yeah, that's going to clamp, but it needs to like go, it needs to reset. Like it needs to rebuild up again. So this is just a global counter that increases by 1, but then I need to be like, alright, yeah, once it reaches 7, it needs to go back to 0 again. But if it's like 8, 9, 10, 11, 12, 13, 14, 15... Yeah, can I test this in Nebula? I'm just going to test this in Nebula, because that... I think you guys might know this faster than I do, so, you know, bear with me. I think I have standard clamp in here that I can just use. What on earth is going on here? I don't know, so I'm just going to delete everything. IO stream. Right, so then include maths, C maths, or math. I have a value, so just going to set a for loop. Set it to uint32. I is equal to this, which is 0. Let's say 1,000. I don't know. That doesn't really matter. Let's say 100. It's just a doesn't really matter though. And I want to say, all right. We want to counter. And we say equals. So. Oh, do we have clamp in this? Oh yeah, that's exactly what I wanted. Is there a standard clamp? What is that? Oh, it's an algorithm. Of course. For some reason, it's an algorithm. Right. Okay, so so the value is I, lowest value is this, and the highest value is 7. Oh, what does it return? Yeah, what is it? Alright, const t, oh, it's templated, it's fine. Okay, that makes sense. I mean, how else is it gonna work this out? Alright, cool. And then I'm just gonna print, because what I think what's gonna happen is it's just gonna be 7 over and over and over again. Value equals, I know I'm flushing the buffer. It doesn't really matter though. Counter. Alright, cool. Yeah, that's what I don't want it to do. So that's half the problem. I'm so tired of going to bed. Oh, thank you for joining us for so long. Angelica is a cutie. And look at that. You're number 1 as you leave. Well, have a good night's sleep anyway. Take care, dude. Right. How'd you reset? What is it? What do you exactly want to do? I want to go like 1 2 3 4 5 6 7 1 2 3 4 5 6 7 1 2 3 4 5 6 7 over and over and over again. So I want a system where we kind of like reset to 0 every single time. I think what we need to do is the only thing I'm missing actually. Now I've said that out loud. You need to make sure then. You need to make sure that you need to make the 50 random then. I see, okay. Ah. Am I? Oh yeah, that's exactly it. Yeah. Oh, yeah. That's... Jeez, you should be programming this engine. Alright, so... Oops, that's not what I want. So we're going to say that... Yeah, so... First things first, we've got to make sure +1 is a thing, and then modulus 10,000, right? But it needs to be prime, so the closest number is... Oh, yeah, there we go. Alright, cool. So that would be remainder 0, but I'll just keep increasing by 1, I assume. So... And the instant count goes up and up and up. We don't need to reset it at all. And as soon as that hits that many instances, we could set like this is a bit lazy, but this might just make the logic easier. First time equals true, and so if you reach in here once, then false. So we need to have this kind of like conditional here, separate. Right, so or, and then like and these two together. So and is first time. Or, oh, sorry, and, sorry, these need to be true together, is equal to false, and this is equal to 0. Alright, so that's a bit of a clumsy bit of way of doing it, but I think if I increase the instantiation amount to, let's say 20,000, so we should have 2 draw calls then. So we're going to have 20,000 particles in the screen, hopefully. We shall see. So we change this to 2. I need a variable here. Dinner time indeed, yep. No, it's my dad. I'm in the kitchen. Yeah, you gotta remember that. I'm in a shared area. Alright, so 20k, and we have 20k instantiations on 64 groups. And what am I trying to do after that? Oh, also the compute share needs to run 20,000 times in the X direction. We'll see. So in theory, oh, and I haven't finished. No, whatever. So the other thing I need to do, otherwise it'll just complain, is in the particle renderer. I'm going to have to chain all these together. I think I might do this after. Instead of trying to go to 1,000,000 immediately. So we should at least have 2 draw calls. As far as I'm aware anyway. Oh, nothing at all, as usual. I think the logic's bad. Alright, so it's this. So we've reached that. Or It's not the first time. An instance count is equal to 0. Oh, that won't work. That would need to be... Yeah, hang on. Yeah, instance count needs to be... Yeah, okay, so that modular is just going to break. So that needs to be like that. In fact, this can be like that, to be honest. That's not going to fix anything. It's just going to make sure the logic makes sense. That's just going to... Yeah, okay. Now, if I get rid of this... I don't know how the computer's going to handle this, but... we shall see. Or else... I'm just going to like write a lazy version here. Get rid of this. That was dumb. I am just going to just lazily kind of copy this over. And kind of do a... yeah, so if... So we can have two conditions here. If this happens, then we do that. If that happens, we also do this. So if this instance count... I want to say this, right? That doesn't make any sense. Okay, so I got an idea. What's the next? So yeah, if that, sorry, if the instance count is equal to 1106, then do that as well, because that'll reset at 1000 thingamajiggy. 83. Oh, yeah. Yeah, okay, there we go. That's 20,000. That's 20,000 thingies. And we can normalize them all so we can see it's basically a full sphere if we're interested. Normalize. So you'll see it's like more dense. It should be double the density. Alright, so let's increase it again. So we should go to 4 now. So I'm just going to double it. So we're going to get to 40k. Ish. So we're getting there. This is mostly just to see if my ideas have worked at all. So I'm going to make a variable, I think, even if it's just floating around. So number of particles is just going to be here. So const expr oops. Particle count. So I'm not going to change this at any point, so it's just that instead of having a magic number here, you can just increase the amount. We'll see how this goes. So this should be 4 draw calls. Damn. Okay, so if I take roughly 1 million divided by 10k, what do we get? We get 100 draw calls. So let's do that in 100 draw calls with 1 million particles. So 1. Let's just make sure I write 1 million. And I'm gonna do 101 just to be safe. Alright. This might be just completely crap. Or you might run out of space. I have no idea what's gonna happen. Okay, so that's 1 million particles. Fair enough. I'll wait for it to get bigger because it often struggles. Yeah, when we're looking at a lot of particles all at once. We wouldn't ever do this, by the way. Putting all the particles in one place is really bad. Wait for it, wait for it. There we go. It'll speed up once they've started to spread out. There we go. There we go. Oh, I see what's happened there. We've got the same number of particles, but all in the same place. Change the speed from... Alright, so that's why it went so slow. But effectively, we're getting there. Yeah, okay, so I can improve that. So yeah, that's 1 million particles. It was a bit tanky, but it's also my logic kind of putting all the particles in the same place. Because this seems to get reset at a particular point. We would need like 1 million unique positions to do this with one particle simulation. Which is fine, but I just don't think we have enough random... I don't think this goes that high, you know? I mean, maybe we could like multiply it by like... I don't know. 100 or something. I mean, let's try it. I don't know. I need more unique positions. And what you're saying? Change the speed from 50 IDs to... That should give you N shells. Instance ID, sure. Yeah, screw it. Let's do that as well. So this is the instance ID. That's the do you mean the global instance ID? Like how many invocations we have? Like that. So what global invocation we're on? So let's just try and increase the numbers that we can get of like randomness. We'll see. We'll see if that works. Or we just completely... Whoa. Jeebus. Just exploded out in different directions. Oh, that's why. Yeah, that invocation's probably too big. And also, still, we've got like loads of particles all in one place. That's why this almost looks like perfectly like a full-on blue sphere, right? That's like we've got like 10,000 like particles all in one place. No, I don't think that works. Hang on. All right, let's just see if we increase the amount of particles in the positions that they see them in. Okay, so that's just so slow. Oh, okay, right. So we'll take this then, and we'll... Yeah. I'll just surround all this. That hopefully will increase the speed differences. Oh, some of them are moving in. What is happening? I think they're moving, but it's just really slow. So let's just speed that up. Let's do 100 or something. That was really slow. Yeah, it's it's still you can see the issue, right? We're actually getting less particles in different unique positions. Okay, so that actually made it worse, I think. Let's reduce that then. Yeah, wait for it. Wait, once we stop looking at them. Again, we would never do this. I think it's the same deal though. Okay, so that's like basically back to where it was. Now if I just increase this number, do I get like a random number between these values or something? I don't know. Again, I'm just experimenting here, so some of these values might be dubious at best. Okay, so clearly we must have exceeded some kind of value here. Where is everything gone? Really? Doesn't that look less? Oh, I see. It's just flying off. Yeah, we need like I feel like we need to send in random numbers, you know? Because we're just not getting enough. Because it's just, that's part of the reason why it's so slow. Is because we're getting like, we have 1 million particles, but we're kind of rendering them all in the same place. Let's get rid of the normalize and just see how that looks, right? That might be restricting like how many random... Yeah, I think that's... Ooh. This. Yeah, I think it's restricting like how many random points we have in space. I think. Oh. Where is everything? Alright, so let's try again. Okay, so that does what? That does the original, right? I'm just going to stop it immediately. I'm not going to bother waiting. Yep, okay. So now what we want to do is get rid of the normalize. What? So yeah, that should be that and that, right? But I think, yeah, okay, so I've kind of lost it a little bit with the semicolons. Oops. So 1, 2, 1. So we have 1, 2, 1, 0. I'm gonna get rid of this normalize. I'm gonna comment this out just briefly. Okay, that doesn't work. I'm just gonna bring it back to 50 just so we can see it all work again. And I'm just gonna make the cube. Yeah, because we're very limited here with the amount of things we got. So hopefully, yeah, that's doing the same thing, more or less, anyway. And now, what I want to do is get rid of this, right? So that should be a cube, or at least still be doing the same thing. No, it's just going off to the left. I think maybe because this needs to happen first. So hopefully, again, because we're looking at the particles, they'll go way slower. Because it's having to do a lot of work. Whoa, okay. And next time I won't move the camera. Okay, so we're just getting bombarded with them at the moment, which is normal. I guess this is what a million particles looks like. 1 million particles. Now we're still getting the issue of multiple particles overlapping each other. You know? But it's probably not as bad. Yeah. Like multiple particles overlapping each other is like yeah, my eyes, I apologize. But we are able to render a million particles, but just I think I'm just being it's the random number that I'm not able to generate. I'm not able to I'm not able to randomly generate like a million random values. Like a million random floating point values. Really. So I am struggling. So they can render, but when they're all on top of each other, it just does not play ball. Just because I think there's a load of wasted work happening. It constantly has to go over and over and over itself, over and over again. So we end up with this bad situation where is this? Yes, this. Thank you. Where it has to throw away work over and over and over again until it like starts to understand what to do. Once I've spread everything out. Oh, thank you just watching. That's really nice. Honestly, thank you for all the support in the stream. It's been honestly such a pleasure. So, yeah, there it is. Look there. Thank you. Thank you very much for that. It's really nice. So we are rendering particles. I think what I need to understand next is how to do this, how to do particle effects. I think I might spend a couple of days, if that, like working on particle effects. Not because I need to understand, like, not because I need particle effects exactly, but like, just because I need to understand, like, yeah, well, I do need to do particle effects, but if I'm able to test this, yeah, then GPU party, yo-ho, there we go, yep. I need to be able to, you know, I need to be able to simulate stuff like, oh, thank you, another one, thank you, thank you so much for honestly supporting the stream. It's just watching. Thank you so much, honestly, it's really nice. Again, I'll try and get this to work on the screen, but I think I need to add more. I need to add a widget or something that like, can edit the video live or something. So yeah, I'll try and get that to work and stuff. You can change. Ooh. Change 50. Yeah, let's try that. Let's see what that does. So random. Yeah, I didn't think about changing the speed actually. That's quite clever. Nice work there. So vec2, yes. So we need to. So it honestly might be a bit of a strange. I don't know what we're gonna do tomorrow, but yeah, this is kind of interesting, like randomizing the speed as well, at which they are flung out. Oh, there's no such thing as ran on. Let's have a look. What do we get? Yeah, because that would stop them overlapping as much. Actually, that's quite smart. Yeah, again, we're gonna have to. I'm just gonna have to sit here and wait. So yeah, just gonna let it grow. It's like the Big Bang. We're starting off the blue Big Bang. So yeah, once we've escaped, and the GPU can do some optimizations once we're not looking at blue anymore. This is literally how the Big Bang happened, guys. Some Vulkan programmer accidentally made too many particles and you know, restarted the universe as we know it. You know how it is. Us Vulkan programmers. Okay, come on. Stop being blue. This is a good sign though, because now we're getting like variant speed. Is there can I back out of this without like causing frame rates to dive even worse? Okay, there we go. Is it better? Yeah, that is better, but it's still not ideal. You can see how many more particles we got though. We got like an insane amount of particles. Like there's multiple like thousands overlapping this. That's why it looks so like perfectly blue. But yes, we have managed to render more of them uniquely, right? And obviously as it spans out, it would look more. Oh, are you drawing them? Lol, indeed. Oh, are you drawing instance? Yes. Are you indexing them particles correctly, or not just drawing them the same set multiple times? Ah, that might be it. You're right, because I am instance drawing them. Yeah, I think I might be like redoing the same buffer over and over again. But I don't think so though. But it is a possibility. Well, anyway, I'm going to share my Discord server with you guys. I hope you've all had a fantastic stream. I'm going to call it here. And oh, okay, I'll do it on my. See, I'm so half asleep that I can't remember how I usually share these things. But yes, thank you, Can't Touch This for all the help, and thank you for everyone and TT and everyone like that. Looks amazing. The yeah, I'll make this simulation actually generate millions of particles. I think there's some other issues that are causing this to happen, but anyway, yes, thank you for the stream. It's honestly been all the support has been absolutely wonderful. Thank you guys. You've been honestly you've been a really awesome community to be around, and despite being such a small content creator, it's been you know flattering, honestly, being looked upon like this. So yes, I'll end it here for you guys, and I'll see you hopefully soon. Yeah, thank you for all the gifts as well, just as we leave. All right, bye guys. All right, bye, take care, keep up the grind. Will do. You too, dude.